Welcome back to the Snoozy Scientist, your quiet place to drift into rest while still letting curiosity roam. Tonight, we're traveling back more than 12,000 years to a fragile period just at the end of the last great ice age. Glaciers that had covered vast parts of the planet were pulling back mile by mile. Forests were spreading, grasses rising tall, and rivers once locked beneath glaciers were flowing free. Herds of mammoth and bison roamed the tundra. For the first time in tens of thousands of years, the planet was warming. For humanity, it was a time of fragile hope. People were beginning to linger in fertile places, gathering wild grains, storing food. In the Middle East, the first villages hinted at a different kind of life, not just wandering, but staying, planting, building. The world seemed to be stepping into a gentler age. After millennia of wandering, they were starting to dream of permanence. And then, without warning, it stopped. The warming collapsed. In less than a human lifetime, the planet was thrown back into bitter cold, a sudden freeze that would last not a year, not a century, but 1,200 years of harsh winters and almost non-existent summers. Forests turned back into tundra almost overnight. Cultures balanced on the edge of farming collapsed, their hopes buried beneath endless winter. This sudden mysterious deep freeze has a quiet name, the Younger Dryas. But behind that soft-sounding name lies a catastrophe whose cause is still being debated by scientists today. Some argued that a massive comet may have struck Earth, igniting fires and cooling the climate, but others point to floods of glacial meltwater choking the oceans. To this day, science is still searching for the answer. Tonight, we'll step softly into that frozen world and explore how survival, extinction, and unanswered questions shape the future of every living thing. But before we begin, I'd love to know, where in the world are you listening from tonight, and what time is it there? Your comments are one of my favorite parts of this sleepy little community. If you're enjoying these late-night explorations, a like and a subscribe would mean a lot. And for those already subscribed, thank you for being part of this calm little corner of science. If you haven't yet, kindly tap the notification bell so you won't miss the next upload. And here's a small joke to ease us in. Hopefully these facts won't be so fascinating that they keep you awake all night. But if they do, at least you'll slip into tomorrow with a head full of knowledge. Now take a slow, deep breath. Let your shoulders relax. Close your eyes if you'd like. And together, let's drift quietly into the 1,200 long years winter that nearly erased civilization before it began. Around 14,700 years ago, the world was in motion. The deep cold of the last ice age had begun to loosen its grip. For tens of thousands of years, colossal glaciers had pressed down upon the continents, carving valleys and grinding stone into powder beneath their slow, relentless weight. Now, those walls of ice were retreating, step by step, releasing the land they had held prisoner for so long. In North America, the Great Laurentide Ice Sheet, once stretching as far as the horizon in every direction, began to thin and pull back toward the north. In Europe, the vast ice cap that had covered Scandinavia shrank, uncovering lands that had not felt the warmth of the sun in ages. Even in the high mountains of Asia and South America, glaciers that had once poured into valleys were retreating uphill. The earth itself seemed to exhale after an age of silence. As the ice retreated, ecosystems stirred into being. Where once there had been nothing but ice and stone, meadows of grasses began to spread. Hardy shrubs rooted themselves in the raw soil, soon followed by forests of birch, pine, and eventually oak. Rivers, fed by meltwater, roared with new energy, carrying minerals and soil downstream to nourish the ground. Lakes formed in the shadows of melting glaciers, shimmering like new mirrors laid across the landscape. The land was greening, and life hurried in to fill the space. The warming brought abundance. Herds of grazing animals thrived in the grasslands that spread across Eurasia and North America. Giant bison, elk, and caribou moved in vast migrations, followed by predators that shadowed them at a careful distance. In the river valleys, fish darted in the fresh waters that poured through channels newly carved from melting ice. Birds followed the seasonal rhythms, nesting along the edges of wetlands that had not existed just centuries before. For every creature that returned or evolved to fit these new spaces, the earth seemed to hum with possibility. Humans, too, found new opportunities. For generations, survival had meant endless movement, following herds through icy winds, scavenging plants in frozen soils, huddling for warmth in caves and makeshift shelters. Now the land was kinder. In Europe, groups of hunter gatherers explored the forests and valleys as they spread, harvesting berries, nuts, and tubers alongside the hunt. Across the plains, hunters tracked mammoths and reindeer, but now with greater security, as food was no longer as scarce as it had been during the height of the Ice Age. Farther east, in Asia, people thrived along rivers swollen with meltwater, where fish and waterfowl were plentiful. In the Americas, the retreat of the glaciers opened corridors into landscapes that had been unreachable, allowing humans to spread into new territories filled with game. And in the Fertile Crescent of the Middle East, the shift was even more profound. The warming created a patchwork of fertile valleys and wild grasses. For the first time, people began to linger in one place longer than before. They discovered that seeds scattered on the ground would sprout again where they had been dropped. They harvested wild cereals and stored them for later. It was not yet farming, not in the way it would become, but the first quiet experiments had begun. The air itself told the story of a shifting planet. Ice cores taken from Greenland reveal how temperatures rose with astonishing speed. In just a matter of decades, the world warmed by several degrees, an immense change compared to the glacial rhythms of the past. To the people living then, the change would have felt subtle in any given year, but the passing generations noticed. Winters were still cold, yet they no longer stretched endlessly. Summers grew warmer, and plants once rare began to spread. Each year carried with it a sense of cautious hope. In this window of warmth, human cultures blossomed. Tools became more refined, shaped for specific purposes. Stone blades were crafted for harvesting plants, while spear points were designed for precision hunting. Shelters grew sturdier as people found reasons to stay longer in one place. Social bonds strengthened, not only out of necessity, but out of choice, as groups came together in larger communities. Songs, rituals, and art flourished, reflecting the growing sense that the world was changing for the better. The retreat of the glaciers also reshaped the face of the planet. As ice melted, sea levels began to rise. Land that had once connected continents slowly disappeared beneath advancing waves. Coastal plains where humans had walked were swallowed by the sea, leaving behind only the memory of ancient shorelines. Yet at the same time, newly opened lands offered fertile ground where ice had once dominated. For every world lost to water, another was given back by retreating ice. It was an age of transition, full of both endings and beginnings. Mammoths still walked the plains, but their herds roamed alongside forests that had been barren just centuries before. Humans still hunted and gathered, yet they were beginning to imagine new ways of living. Rivers that had been bound in ice now carried life-giving waters to valleys ready to bloom. For the first time in a long while, the planet seemed to promise abundance, and life hurried to accept the invitation. As the glaciers pulled back and the world began to warm, the melting ice released unimaginable quantities of water. For tens of thousands of years, that water had been locked away, stored in frozen sheets that stretched for miles across continents. Now it flowed steadily back into the oceans. global sea levels began to rise, and the face of the Earth itself started to change. At the height of the last ice age, so much water had been trapped in ice that the oceans were far lower than they are today. Vast stretches of land lay exposed, coastlines reached far beyond their present limits, and wide plains connected regions that now lie separated by water. As the melt quickened, these landscapes began to vanish. The sea crept inland, swallowing shorelines that human feet had walked for generations. The waves returned to places that had been dry land for thousands of years, erasing entire worlds beneath the tide. One of the most dramatic examples of this change was the land bridge that once connected Asia to North America. During the Ice Age, the shallow floor of the Bering Strait was exposed, forming a vast plain known as Beringia. Mammoths and bison roamed it freely, and human groups followed, carrying their lives across an open highway of grass and tundra. But as the ice melted and the seas rose, Beringia began to sink beneath the waters. By around 11,000 years ago, the land bridge had disappeared completely, cutting off continents and leaving only the narrow strait we see today. Similar stories unfolded across the globe. Between Britain and continental Europe stretched a fertile region of rivers, lakes, and grasslands that we now call Doggerland. It was a world rich in fish and game, a place where humans lived and thrived. Rising seas eventually drowned it, leaving only scattered fragments beneath the waves of the North Sea. To the people who once called it home, the transformation must have been bewildering. Shorelines that had seemed permanent shifted year after year, and places once familiar disappeared into the sea. On the other side of the world, Australia and New Guinea were once connected by broad land known as Sahul. Human communities had spread across it during lower sea levels, building lives in landscapes that no longer exist. As waters rose, Sahul broke apart, isolating the islands we recognize today. Every continent bore witness to this slow but relentless reshaping. The loss of land was only part of the story. At the same time as the oceans took, the retreating ice gave. Where glaciers had once pressed down upon the land, their weight melted away. In their place came new valleys, fresh rivers, and wide plains. These regions were raw, scarred by the passing of ice, but they were also fertile. Minerals ground to powder beneath the glaciers enriched the soil. Meltwater nourished the land, creating marshes, lakes, and meadows. Where ice once suffocated, life now returned in abundance. For humans, the changes brought both challenge and opportunity. Rising seas forced groups to move inland, abandoning lowlands that had been home for generations. But the newly opened territories offered fresh hunting grounds, rivers teeming with fish, and fertile soils that would one day invite agriculture. The earth was in transition, and humanity had no choice but to move with it. In the Fertile Crescent, the patchwork of valleys and river plains grew even richer. Seasonal floods laid down layers of silt, dark and nourishing, ready to support wild cereals and grasses. It was in these places that people began to build more lasting settlements. Storage pits appeared, stone tools for grinding grain became more common, and the first steps toward agriculture gained momentum. It was not yet farming in the full sense, but the foundations of it were being laid, stone by stone and seed by seed. In other regions, coastal peoples who had once relied on vast exposed shorelines for food were forced to adapt. As the seas rose, they turned to fishing in deeper waters or sought new homes farther inland. These shifts were not sudden in the sense of a single storm, but across generations, the changes were unmistakable. Grandparents could point to places that no longer existed, telling stories of rivers that flowed where now there was only ocean. The rising seas also changed the rhythms of migration. Routes once open across land were cut by water, isolating groups from one another. Yet rivers and coasts also became highways of connection. Boats, rafts, and simple canoes allowed people to travel, to fish, and to carry goods. Waterways that had once been barriers now became paths, shaping trade and cultural exchange long before cities or empires existed. The earth itself seemed to be resetting the stage. Old worlds vanished beneath the tide, but new ones opened as the ice withdrew. Fertile plains invited human hands to stay longer, to shape the land more deliberately. Rivers provided food and pathways, binding communities together. Shorelines shifted, sometimes cruelly, sometimes generously, but always reminding life that nothing on earth is fixed forever. The seas advance and the ices retreat were not only physical changes, they altered the imagination of those who lived through them. Myths of floods and drowned lands echo in cultures around the world, perhaps faint memories of these ancient transformations. Stories told around fires carried warnings of waters that could rise, of lands that could vanish. For those who listened, the world was not static, but alive, changing, and unpredictable. In this age of shifting shores, humanity stood between loss and possibility. The seas took much, but the land offered much in return. And it was in this balance of endings and beginnings that the first true seeds of permanent settlement began to take root. As the glaciers retreated and seas rose, the landscapes of the Near East took on a new character. In the valleys and hills of what we now call the Levant, stretching from modern day Israel through Jordan, Lebanon, and Syria, the warming climate created a patchwork of fertile ground. Here, wild cereals like barley and wheat grew in thick stands, swaying in the breeze across the open plains. Almond and pistachio trees scattered their fruit, while gazelles, birds, and fish offered rich sources of protein. To human eyes, this was a land of promise, where survival no longer depended only on the endless chase of migrating herds. The people who lived here belonged to what we now call the Natufian culture. They were hunter-gatherers like countless generations before them, but they were also something new. They began to stay longer in one place, building stone foundations for houses and creating small settlements that might last through seasons rather than days. These communities were not yet cities, not even villages in the way we think of them now, but they were the first steps toward a life tied to the land. In the fertile fields, the Natufians noticed the abundance of wild grains ripening each summer. Instead of merely gathering what chance offered, they began to experiment. They cut stalks with stone sickles, the edges of which grew shiny and worn from repeated use. They ground the harvested seeds into flour with heavy mortars and pestles, creating new textures of food that could be stored and shared. For the first time, humans were shaping the rhythms of nature to meet their needs. Storage became essential. The Natufians dug pits lined with stone or clay, creating dark, cool spaces where grain could be preserved long after the harvest. These pits meant that food could last through leaner months, a buffer against hunger in a way the Ice Age world had rarely allowed. This ability to store surplus gave their communities resilience, making it possible to plan for the future rather than living only from day to day. Archaeological traces reveal their ingenuity, grinding stones, some so heavy they could not have been carried far, suggest that the Natufians intended to remain in one place long enough to use them year after year. The wear on these tools shows repeated grinding of cereals, evidence of daily routines built around plants rather than only around animals. This was not yet full farming, since the grains were still wild and gathered from the hillsides, but it was a decisive step in that direction. The Natufians also shaped their environment in subtle ways. As they harvested and carried seeds, some fell to the ground near their camps, sprouting again the next season. Over time, these accidental plantings may have encouraged people to think of sowing intentionally. The connection between seed and harvest was an insight that carried profound consequences. Each discovery whispered that the land could be persuaded, that plants could be coaxed into yielding food, not once, but again and again. Their settlements reflected these changes. Circular stone houses with hearths at the center offered warmth and permanence. The presence of cemeteries, with carefully buried individuals, suggests a deeper relationship with place. These were not people who simply moved on when resources thinned. They returned, remembered, and rebuilt, creating traditions tied to the land itself. This stability encouraged new expressions of culture. Ornamental beads, carved bone tools, and decorated objects appear in Natufian sites, hinting at communities that had the time and security to make things beyond what was strictly necessary for survival. Social bonds deepened as groups grew larger, bound together by the shared effort of harvesting, grinding, storing, and defending food supplies. Where life once depended on small mobile bands, now larger groups could thrive in fixed locations. It is easy to imagine the scenes: a hillside golden with ripening barley, families bending to harvest with stone sickles, children carrying baskets of seeds back to camp, smoke rising from hearths where bread like cakes baked on hot stones. Around them, the sounds of life filled the air: the cries of gazelles in the distance, the calls of birds, and the steady rhythm of grinding stones echoing like a heartbeat. The Natufians lived on a threshold. They had not yet domesticated plants or animals, but they were poised on the edge of that great transformation. In their world, farming was not a revolution that happened overnight, but a slow unfolding. Each season of harvesting, each seed accidentally dropped near a camp, each tool shaped for gathering, was part of the long story that would one day lead to agriculture. This delicate balance between gathering and cultivating held enormous significance. It allowed humans, for the first time, to envision a life that did not rely entirely on following herds or wandering with the seasons. It was a vision of permanence, of roots both literal and symbolic, stretching into the soil. What began as small experiments in harvesting wild grains would, in time, change the course of history. As the warming years unfolded, the earth was not only reshaping its rivers, forests, and coasts, it was also reshaping the lives of the people who called it home. In every corner of the world, groups of humans adapted to the shifting landscapes, each in their own way, but all sharing in the new abundance that a gentler climate provided. Across North America, a culture flourished that we now call the Clovis. They lived more than 13,000 years ago during the heart of this warming period, and their name comes from the distinctive stone points they left behind, first discovered near Clovis, New Mexico. These tools were more than simple weapons, they were precision instruments of survival. Long, fluted spear points with elegant grooves running along their sides, they were crafted with skill and patience. Each point carried the mark of hands that knew exactly how stone would break under pressure. With these tools, the Clovis became masters of the great megafauna that roamed their world. Herds of mammoths still thundered across the plains, their massive tusks curling like ivory crescents. Giant bison gathered in thousands, shaking the ground as they moved. Horses, camels, and ground sloths, all far larger than the animals we know today, filled the landscapes of North America. For the Clovis people, these creatures were both a gift and a challenge. A single mammoth could feed a community for weeks, but bringing one down required careful planning, teamwork, and bravery. Evidence from kill sites shows how coordinated these hunts were. Hunters drove herds into natural traps such as swamps or steep ravines, where the animals became vulnerable. Spears tipped with Clovis points struck deep, and once a creature fell, the entire group worked together to butcher and preserve the meat. Nothing was wasted. Bones became tools and shelters. Hides became clothing. Tendons became thread. Each hunt was not just a moment of survival, but an expression of human ingenuity. Far across the Atlantic, Europe was also alive with abundance. As the glaciers retreated, game animals spread into newly opened forests and plains. Red deer, aurochs, and wild horses roamed freely, offering hunters a reliable source of food. Groups of people followed the herds, moving with the seasons, carrying their belongings with them. They were nomadic, but not rootless. Camps left behind showed traces of hearths, stone blades, and ornaments made from bone and shell. Art flourished too, as cave walls became canvases for scenes of hunts, rituals, and visions of the natural world. In Asia, nomadic groups thrived on the great steppes that stretched endlessly across the land. These grasslands were alive with wild cattle, antelope, and gazelle. Hunters here used bows, atlatls, and finely worked stone tools to pursue their prey. The wide open spaces allowed for vast migrations, not only of animals but of people. Families carried their lives across great distances, tracing the paths of the herds. Archaeological finds reveal beads and carvings traded across hundreds of miles, proof of networks of contact and exchange that tied distant groups together. The warming climate brought more than game and open land. It also meant longer growing seasons for plants, more predictable patterns for rivers, and richer ecosystems overall. With this came an increase in human population. Where once small bands struggled to survive in the lean world of the Ice Age, now larger groups could thrive. More mouths could be fed, more hands could share in the work of hunting, gathering, and building. Settlements grew larger, even if they were still temporary. Social ties deepened, as cooperation was the key to managing both the bounty and the risks of this new world. The abundance also encouraged diversity in how people lived. In some places, groups remained highly mobile, moving often to follow herds and seasonal plants. In others, people began to settle for longer stretches, making use of rich local resources. Along rivers and lakes, fishing became increasingly important, and with it came new tools such as hooks, nets, and carved boats. Each innovation was a small step toward shaping environments rather than merely surviving within them. The warming years were not without their challenges. The great megafauna were still dangerous, and hunts could be deadly. Weather was less extreme than before, but storms, droughts, and sudden cold spells could still strike without warning. Disease, accidents, and conflicts between groups were part of daily reality. Yet, compared to the harshest days of the Ice Age, life carried a rhythm that allowed for growth and even creativity. The evidence of this creativity lingers in the artifacts left behind. Carved figures of animals, jewelry made from teeth and shells, and decorated tools suggest a world where humans had enough security to make beauty part of their lives. Ritual burials reveal care for the dead, with bodies laid to rest alongside ornaments and tools, gestures of respect and memory. These practices hint at belief systems, stories, and identities that bound people together in ways that went beyond mere survival. Across continents, the warming Earth provided a stage upon which human cultures grew more varied and complex. From the mammoth hunters of North America to the deer hunters of Europe and the steppe nomads of Asia, each group was shaped by the animals they pursued, the landscapes they inhabited, and the resources they could gather. The diversity of lifeways reflected the diversity of the earth itself, as glaciers withdrew and life reclaimed the land. In these centuries of warmth and growth, humanity was learning what it meant not just to endure but to flourish. Populations expanded, ideas spread, and human presence became more deeply woven into the fabric of ecosystems. The future was not yet certain, But for a time, the path seemed to point toward abundance and possibility. For many centuries, the Earth had been warming. Glaciers that once locked the continents in silence were retreating, rivers flowed more freely, and life seemed to be entering a gentler age. Human groups were exploring the possibilities of new ways of living, gathering wild grains, and imagining that the endless winter of the Ice Age might truly be behind them. Then, around 12,900 years ago, something astonishing happened. The change was not gradual, like the long pulses of warming and cooling that usually shape the planet's climate. It was sudden, sharp, and devastating. The warming stopped, and in the space of only a few decades, the Earth was thrown back into a deep and bitter cold. The pace of this reversal is what makes it so extraordinary. In Greenland, where the climate is recorded in the ancient layers of ice, average temperatures fell by as much as 10 degrees Celsius within a human lifetime. To put that in perspective, the difference between today's climate and the height of the last ice age was only about 5 to 7 degrees. Here, in less than a century, the world lost even more warmth than that. For those who lived through it, the change would have been unmistakable. A child born into summers with flowing rivers and green valleys could have grown old in a world of biting winds and relentless frost. The Greenland ice cores, drilled deep into the frozen sheet, carry this story with exquisite precision. Each layer of snow compressed into ice, trapping tiny bubbles of air that hold the breath of ancient skies. Scientists studying these layers see a sharp step downward, a line as clear as a broken bone in an X-ray. Within just a few centimeters of ice, thousands of years of gentle warming were cut short. The Younger Dryas had begun, and with it, the planet seemed to draw back into winter as if startled by its own momentum. What made this shift so disorienting is how out of rhythm it was with the natural cadence of Earth's climate. Normally, changes unfold over thousands of years. Entire species can adapt, move, or evolve in that time. But this freeze collapsed upon the world in the space of a few decades, a blink in geological terms. Imagine standing on the edge of spring, watching the days lengthen and the warmth return, only to find that in the same lifetime the seasons falter, summers shorten, and the air thickens with cold. That was the reality of the sudden chill. The shock echoed far beyond Greenland. Across the northern hemisphere, weather patterns faltered. Storms grew harsher, winds carried dust farther, and regions that had begun to flourish under gentler conditions faced abrupt setbacks. Lakes froze earlier in the year, and snow lingered long past its usual time. These were not slow encroachments that could be adapted to gradually. They were abrupt and unsettling, the kind of shifts that forced entire generations to rethink survival. For human communities, the bewilderment must have been profound. In fertile valleys of the Middle East, where people had been experimenting with storing food and tending wild plants, the climate swung suddenly back to cold and dry. Hopes of permanence would have withered almost as soon as they were planted. In North America, where groups like the Clovis people had hunted vast herds across wide plains, conditions shifted so rapidly that their way of life dissolved within centuries. These were not the long, grinding pressures of slow climate change, but sharp breaks that demanded immediate response. The natural records show the disruption clearly. Dust deposits in the ice cores thickened, hinting at fiercer winds that swept across continents. Those winds carried fine particles that darkened snow and ice, altering the way the earth reflected sunlight. This small change amplified the cooling, a feedback loop that reinforced the sudden plunge. It was as though the planet, once nudged, cascaded into a deeper freeze that it could not easily escape. The causes of this abrupt reversal remain a subject of intense scientific debate. Some argue that immense floods of glacial meltwater pouring into the North Atlantic disrupted the great conveyor belt of ocean currents that distribute heat around the globe. Others propose that volcanic eruptions or even an extraterrestrial impact might have triggered the shift. Whatever the trigger, the outcome was the same. A world on the verge of warmth was hurled back into cold, its progress toward a new chapter of life abruptly stalled. What stands out most is the sheer speed. Generations that had expected a gentler climate instead passed on memories of sudden scarcity and renewed hardship. The archaeological record reflects the strain in vanished cultures, disrupted patterns of settlement, and sudden breaks in tradition. In the ice, in the sediments, and in the faint traces of vanished human communities, the story of the sudden chill is written. It is a reminder that the Earth does not always move in slow cycles, and that sometimes its changes arrive with breathtaking speed, overturning the world within a single human lifetime. When the warmth of the Earth faltered and the cold crept back across continents, life adjusted in ways both subtle and profound. Glaciers once again pressed outward, forests withdrew, and the air carried a sharp edge. Among all these great changes, one small and delicate plant quietly flourished, leaving its imprint on the landscape and on history. That plant was Dryas Octopetala, the mountain avens, a tundra flower with 8 white petals like fragile rays of sunlight against the frozen ground. In the sudden chill of 12,900 years ago, where many plants withered under harsh winds and short growing seasons, Dryas Octopetala found its moment. It was adapted to the cold, hardy in poor soils, and resilient in thin air and harsh light. Where forests retreated and grasses failed, this flower spread, carpeting the tundra with pale blooms that seemed almost ghostly against the dark soil and lingering patches of snow. The rise of this plant was not just a sign of beauty in a grim age, it was evidence of the world's sudden reversal. Scientists studying ancient pollen trapped in lake sediments discovered layer upon layer rich with Dryas pollen. In those tiny grains, no larger than a speck of dust, was proof that climates had shifted quickly. The warming that had allowed trees to move northward was halted, and in their place came the tundra blossoms, spreading wide across Europe, Asia, and North America. This is why the sudden freeze was given its quiet name, the Younger Dryas. It marked not only a span of cold years, but the dominance of a flower that thrives in icy landscapes. To speak of the Younger Dryas is to remember a world where this small plant stood as witness to the planet's abrupt change. The flower itself had no voice, yet it testified through its survival, leaving behind a botanical record that could be read thousands of years later. The naming of great events after delicate details is not uncommon in science. Where volcanic ash layers carry the memory of eruptions, and where fossils give their names to eras, here it was a bloom that came to symbolize an age. The choice reflects how even the smallest of living things can stand as markers of the vast rhythms of the earth. Dryas Octopetala has other stories to tell as well. Even today, the flower can be found in the Arctic and on alpine slopes of mountains, growing close to the ground to escape the wind, its leaves evergreen and leathery, its roots gripping tightly into rocky soils. In summer, the blossoms open wide, and in winter, the plant endures beneath snow and ice, waiting for another brief season of light. It is a survivor, shaped by climates that test endurance. By tracing the abundance of its pollen in ancient layers, scientists can map not only the spread of tundra, but also the timing of climate shifts with remarkable precision. Each layer of sediment, deposited year after year at the bottom of lakes, holds a diary of vegetation. A sudden rise in Dryas pollen is like a line written in bold, declaring that the earth has grown cold again. When the warming returned after 1,200 years, the presence of Dryas declined just as suddenly, replaced once more by trees and grasses. The flower's record is as sharp as a turning page. The quiet dominance of Dryas Octopetala also rippled outward to affect the creatures of the time. Herbivores had to adapt to the tundra diet, feeding on shrubs, mosses, and the hardy blossoms that spread across the land. Mammoths and reindeer grazed on these new fields, their survival tied to the persistence of cold-loving plants. For predators that followed them, from wolves to humans, the presence of Dryas-covered tundra meant the survival of the prey they depended upon. In this way, the little flower was woven into the great fabric of life during the Younger Dryas. The symbolism of the flower is striking. Its petals are bright and delicate, yet it marks one of the harshest reversals in Earth's climate history. It reminds us that fragility and endurance often exist side by side. The tundra bloom does not tower like a tree or dominate like a glacier, yet it became the emblem of an age that almost halted the rise of human civilization. In science, the Younger Dryas remains a puzzle, its causes still debated, but the flower that gave it its name is a certainty. Dryas Octopetala was there, rooted in the soil of a colder earth, spreading as forests retreated and leaving behind its pollen to be discovered millennia later. Each tiny grain became a messenger, carrying across time the story of a sudden winter that changed the course of history. Even today, when scientists extract cores from ancient lakes and sift through layers of mud, they find its presence, marking once again that long winter when warmth abandoned the earth. In the rhythm of petals opening and closing each short Arctic summer, we see an echo of the world that was, and in the fragile white bloom lies the memory of an age defined by cold. The earth had been moving toward warmth, and life had been responding in kind. Longer summers were feeding grasses, rivers ran high with meltwater, and herds of animals roamed with more certainty than they had in generations. Then, almost without warning, the rhythm broke. The Younger Dryas arrived, and the seasons themselves bent under the weight of sudden cold. It was not simply the return of winter, it was the collapse of balance. Summers shortened so sharply that fruits and berries withered before ripening. Young shoots froze before they could stretch fully toward the sun. Winters, once expected to loosen their grip, arrived earlier each year and clung on with unusual persistence. Snow that should have melted in spring remained late into the season, blanketing valleys and delaying the growth of plants on which animals and humans depended. The earth seemed caught in a cycle where warmth never quite arrived. Rivers bore witness to this shift in ways no one could ignore. Waters that had flowed freely in the warmth now froze solid weeks ahead of their time. Ice held them fast through much of the year, muffling their voices and silencing their currents. Fish species that had once depended on predictable thaw found their habitats shrinking. Some spawning grounds froze completely, others dwindled under layers of ice. Creatures that had relied on these waters faced hunger, and predators that depended on those creatures faced it too. The shock to ecosystems was profound. Megafauna that had once dominated the landscape found themselves trapped in a tightening vice of scarcity. Woolly mammoths, so well adapted to endure the chill of the Ice Age, now encountered a different challenge. The food that sustained their immense bodies no longer appeared in the same abundance or with the same reliability. Reindeer and bison, smaller and more adaptable, fared somewhat better, grazing on hardy shrubs and lichens, yet even they were forced into narrower ranges. Predators were among the first to feel the ripple of this unraveling. The saber-toothed cats that had stalked the plains and the dire wolves that had roamed in packs found themselves facing longer, more desperate hunts. Their prey was thinning, herds no longer as vast as they had been. The strength of even the mightiest hunter was nothing without the stability of the food chain, and as herbivores declined, predators followed them into hardship. What made this period so disorienting was its pace. Generations of animals and humans had grown used to slow changes, where shifts in climate played out across many centuries. This was different. It was a disruption that unfolded within the span of a single lifetime. A person born into a world with fertile valleys could live long enough to see those same places locked in a chill where growing seasons failed, rivers froze early, and animals grew scarce. That speed left little time to adjust, and life struggled to catch up. Archaeological records carry traces of this sudden strain. In soils and lake beds, pollen counts show dramatic drops in plants that had flourished during warming. Layers of charcoal appear, suggesting that wildfires broke out as stressed ecosystems collapsed and dried vegetation caught flame. Bones tell the same story, marked with signs of hunger and malnutrition. These remains, whether from animals or humans, reveal how quickly abundance gave way to struggle. The skies, too, bore marks of disruption. Dust, carried by fierce winds, settled across distant lands. In Greenland's ice, thin layers of this dust remain, showing how storms intensified and carried fine particles across continents. These particles darkened snow, reducing its ability to reflect sunlight and deepening the chill. Such feedback loops magnified the disruption, reinforcing the planet's stumble into cold. For humans, the shock was both physical and cultural. Groups that had been finding new security in semi-settled lives were forced to abandon fragile footholds. Resources that had seemed steady were stripped away by the climate's sudden turn. Communities adapted by moving, by reshaping tools, by chasing what remained of game and gathering what hardy plants they could still find. The dream of permanence slipped once again into the necessity of mobility. The Younger Dryas was not only a shift in temperature, it was a collapse in the rhythm of life. Summers lost their promise, winters gained new weight, and the delicate ties between plants, animals, and people frayed under the strain. In every frozen river, in every failed harvest, in the empty bellies of predators and prey, the evidence of a world in shock is still written. It was a reminder that the planet's changes are not always slow and steady. Sometimes they arrive as sharp breaks, rewriting the script of survival in the space of a single lifetime. As the Younger Dryas deepened, the world entered a stage where the great animals of the Ice Age faced their most desperate trials. For thousands of years they had survived the cold, adapted to its hunger, and endured its cycles. Yet this sudden return to winter, this sharp swing back into ice, proved too much for many of them. It was the last chapter for creatures that had once seemed invincible, and their decline marked one of the great turning points in the story of life on Earth. The woolly mammoth was perhaps the most iconic of them all, towering above men, covered in thick coats of shaggy hair, with curved tusks that arced like frozen crescents. These animals were more than survivors of the Ice Age. They were symbols of it. They had endured long winters, roaming wide plains that were rich in grasses. Their molars, ridged and strong, were designed to grind down endless quantities of tough vegetation. But as the Younger Dryas tightened its grip, those plains shrank. Grasslands withdrew, replaced by tundra and low shrubs. Mammoths could adapt to some changes, but they could not find enough food to sustain their immense bodies when the abundance of grasses vanished. Archaeological and paleontological discoveries give us glimpses into their final winters. In Siberia and Alaska, frozen carcasses have been uncovered, preserved in ice for thousands of years. Some still bear intact hair, even the contents of their stomachs, revealing diets of sedges, grasses, and tundra flowers. It is a haunting record. Their bodies, stilled in permafrost, tell of animals caught in landscapes that no longer provided what they needed. For a mammoth, survival depended on vast open steppes where herds could wander and graze. When those steppes disappeared, so did their future. And the mammoth was not alone in its struggle. Across the Americas, giant ground sloths lumbered through forests and grasslands, some standing taller than an elephant when reared on hind legs. They fed on leaves, branches, and fruits, using massive claws to pull down vegetation. But as forests shrank and food sources became more scarce, their slow pace and specialized diets left them vulnerable. Large, heavy, and ill-suited to rapid change, the sloths dwindled. Their size, once a shield against predators, became a burden when the environment shifted faster than they could adjust. Predators, too, felt the strain. The saber-toothed cat, with its long, curved fangs and muscular build, had ruled the plains as one of the Ice Age's most fearsome hunters. Dire wolves, larger than the wolves we know today, moved in coordinated packs to bring down massive prey. These predators thrived as long as the herds were strong. But when mammoths, sloths, and other great herbivores began to collapse, the predators followed. Their hunting skills could not overcome the simple fact that there were fewer animals to chase. Without prey, their reign ended. Scientists once debated whether human hunting played the decisive role in these extinctions, pointing to evidence of Clovis hunters who drove spears into mammoths and bison. While human impact may have contributed in some regions, the Younger Dryas added a deeper pressure. A climate that swung so suddenly, removing food and reshaping ecosystems, created stress that even the mightiest animals could not withstand. It was not a single factor, but the weight of many: changing habitats, shrinking food supplies, hunting by humans, and the cold itself combined to tip the balance. The fossil record reveals the speed of their disappearance. Within a few centuries, species that had dominated entire continents were gone. The timing aligns with the Younger Dryas, suggesting that this freeze accelerated what might otherwise have taken far longer. The collapse of megafauna was not just the loss of individual species, it reshaped entire ecosystems. Without mammoths to graze and trample vegetation, grasslands changed character. Without giant predators, prey animals faced new dynamics. The fabric of life shifted in ways that echoed long after the last mammoth fell. Some isolated groups of mammoths survived beyond the Younger Dryas, stranded on remote islands in the Arctic Ocean. On Wrangel Island, small herds persisted until only about 4,000 years ago, long after the pyramids of Egypt had been built. But these were exceptions, tiny remnants compared to the vast herds that once thundered across continents. For most of the world, the mammoth's last winter came during the Younger Dryas, and with it, the disappearance of much of the Ice Age's grandeur. The emotional weight of these extinctions lingers even today. To imagine a world where mammoths roamed freely, where ground sloths pulled down branches and saber-toothed cats stalked the plains, is to glimpse a planet both familiar and alien. Their loss was not only the end of an age, but also a reminder of how fragile even the greatest creatures can be when climates turn against them. The Younger Dryas left behind more than geological markers and pollen layers. It left behind bones, frozen carcasses, and the silence of vanished herds. The mammoth's last winter was not a single season, but a series of years that steadily closed the door on an entire era of life. And with each passing season, the balance of Earth shifted closer to the world we know today. As the Younger Dryas deepened, its icy grip did not spare the human story. The warming that had opened new doors for our ancestors closed again, leaving people scattered, uncertain, and struggling to survive in a world that seemed to betray them. The very cultures that had begun to flourish under milder skies were suddenly thrust back into hardship, their hopes for permanence scattered like seeds on frozen ground. In North America, the Clovis people had risen to prominence just before the cold returned. Known for their finely crafted stone spear points, fluted and sharp, they were master hunters of the continent's great beasts. They moved across vast plains and forests, following mammoths, mastodons, and other large game that provided food, clothing, and tools. For a time, their culture stretched across the land, leaving behind trails of campsites and tools in soil and stone. Yet, as the Younger Dryas unfolded, the record of the Clovis faded. Archaeologists note a disappearance of their distinct spear points from the layers of time. Whether their decline came from the collapse of the megafauna they hunted, or from the stresses of a climate that shortened growing seasons and altered landscapes, their culture did not endure in the same form. Some groups likely blended into emerging traditions, adapting to smaller prey and shifting environments. But the clear identity of the Clovis, tied so strongly to the hunt of giants, vanished with the giants themselves. Across the ocean in the Levant, another fragile experiment faltered. The Natufians, who had been gathering wild grains and building the first stone houses, were on the cusp of transforming human life. In small villages, they stored seeds, ground them with stone tools, and began to imagine a life tethered to the land rather than endlessly moving across it. They were the first to linger in one place, to shape a kind of community that hinted at the beginnings of farming. But when the Younger Dryas descended, the fertile regions they relied upon grew harsh again. Rainfall declined, seasons grew shorter, and the wild cereals they had once harvested in abundance dwindled. Crops could not take root in the colder soil, and fields that had offered plenty became barren. The Natufians retreated from their settlements, scattering once more into smaller, mobile groups. Their dream of permanence, like the warmth itself, slipped away. The strain of this cold age can be read in the patterns of migration. Populations moved, searching for regions where food remained abundant. In North America, groups shifted southward, seeking lands less gripped by ice. In the Middle East, people turned toward river valleys and pockets of fertility that still offered refuge. Every migration carried both hope and hardship. The lands that could support life became crowded, and with competition came conflict. Scarcity carved new pressures into daily existence. Population numbers, though difficult to measure with certainty, show signs of decline. In many areas, settlements grew fewer, and artifacts became scarcer. Bones unearthed from this time suggest harder lives, with signs of malnutrition, injuries, and shortened lifespans. Humanity, which had begun to rise with the warming world, now teetered under the weight of survival once again. The stress was not only physical but cultural. Traditions tied to abundance had to be abandoned. Communities that had begun to shape rituals around harvests and stored grain found those practices no longer possible. The rhythm of life shifted back toward uncertainty, where every season demanded flexibility and every family carried the risk of scarcity. This was humanity living on the edge, caught between the promise of a new age and the pull of an older, harsher world. Yet, even in this struggle, the adaptability of people revealed itself. Hunters turned to smaller animals when mammoths vanished. Gatherers found new plants and roots to supplement their diets. Tools evolved, shelters were adjusted, and migration paths expanded. Though some cultures collapsed, others emerged, shaped by necessity. The human story did not end in the Younger Dryas, but it was nearly broken by it. What makes this chapter so haunting is how close civilization came to being delayed or perhaps never realized at all. The first steps toward farming faltered, the great hunters lost their prey, populations scattered, their numbers reduced by hardship. Humanity stood on the brink, staring into a cold abyss that might have ended its momentum. Yet somehow, fragile bands of people endured, carrying knowledge and resilience that would later flourish when warmth returned. The record they left behind is sparse compared to later ages, but in its silence lies the weight of their ordeal. The fading of Clovis tools, the collapse of Natufian villages, the thinning traces of human presence across continents, all whisper of a time when survival was nearly lost to winter's return. And though the Younger Dryas lasted only 1,200 years in the long sweep of history, for those who lived through it, it must have felt endless. As the Younger Dryas tightened its hold, scientists have long asked the same haunting question: what could have caused the Earth to slip so suddenly back into cold? Among the ideas that have risen, one of the most dramatic is the possibility that something from the heavens itself played a role, a visitor from the sky that left scars across the planet and pushed the world back into winter. The comet hypothesis suggests that around 12,900 years ago, fragments of a massive comet struck or exploded over parts of the northern hemisphere. The idea is not without precedent. Earth has been struck before, leaving craters and scars that can still be seen today. But in this case, the claim is not of a single obvious crater but of more subtle and scattered evidence, hidden in soils and sediments, waiting to be uncovered by careful hands. One of the first clues came in the form of what archaeologists call black mats. These are strange, darkened layers of soil and organic matter found across North America and beyond. When researchers dug through ancient deposits, they noticed that these blackened horizons appeared at exactly the time when the Younger Dryas began. Above them, the bones of mammoths and other megafauna were scarce or absent. Below them, evidence of thriving ecosystems was still clear. Something about that thin, dark line seemed to mark a turning point. Closer analysis of these black mats revealed more than just charred material. Embedded within were microscopic treasures, nanodiamonds, tiny crystalline structures formed under extraordinary pressure and heat. Such diamonds are often associated with cosmic impacts, the kind of forces unleashed when objects from space collide with Earth. Alongside them were spherules, small round particles that can form when material is instantly melted and then cooled as droplets. Their shapes and compositions bore signatures that some researchers argued were consistent with an extraterrestrial event. The story that emerged was one of fire and sky, a comet, or perhaps a shower of fragments, entering the atmosphere and exploding with immense force would have ignited wildfires across continents. Smoke and soot would have filled the skies, darkening sunlight, cooling the climate, and sending ecosystems into chaos. The suddenness of the Younger Dryas cooling seemed to match such a catastrophic event, a moment where the heavens themselves altered the path of life on Earth. It is a dramatic picture. Imagine flames sweeping across grasslands where mammoths grazed, ash falling like snow onto rivers and lakes, and the sun itself dimmed by a veil of dust. For humans, such an event would have been devastating. Crops that had just begun to be gathered would fail, animals would scatter or perish. Fires would chase people from their camps, and the smoke would leave a mark not just on the land, but on the stories carried forward in memory. And yet, as compelling as this vision is, it remains deeply debated. Many scientists have raised questions about the evidence. Some argue that nanodiamonds and spherules can form in other ways, such as through volcanic activity, lightning strikes, or even human fires. Others point out that the black mats may simply reflect natural changes in water tables or organic decay, rather than continent-wide fires. Replicating the results has proven difficult, with some studies confirming unusual signatures and others finding little evidence at all. The controversy lies in the scale of the claim. A cosmic impact is no small proposal. It requires extraordinary evidence to match its extraordinary nature. While some researchers remain convinced that the Younger Dryas was triggered by fire from the sky, others lean toward explanations rooted in Earth's own systems, such as sudden floods of glacial meltwater disrupting ocean currents. The lack of a clear crater also leaves questions. If a comet struck or exploded with such force, why has no definitive scar been found? Was it a cluster of smaller impacts instead, leaving scattered traces too subtle to be obvious? Despite the disputes, the comet hypothesis continues to captivate. There is something in our nature that looks to the heavens for answers, especially when Earth's story takes a dramatic turn. The possibility that a wandering object from deep space could alter the course of human history adds a sense of cosmic fragility to our past. The debate itself has pushed science forward, encouraging new techniques, fresh examinations of sediments, and broader collaborations across fields. In the end, whether the Younger Dryas was born from floods, volcanoes, or fire from the sky, what matters is the recognition of how sudden and powerful climate shifts can be. The comet hypothesis remains one of the most vivid attempts to explain that great freeze, a reminder that Earth's history is not only shaped by its own processes, but sometimes by the silent travelers that pass near, unseen, until the moment they fall. While some scientists look to the skies for the cause of the Younger Dryas, others turn their gaze to the waters of the earth itself. Here, the story is not of fire, but of flood. It begins with a lake so vast that it dwarfed anything in our world today, a body of water formed by the melting of the last great glaciers. This was Glacial Lake Agassiz, a freshwater sea that once stretched across much of what is now central Canada, covering an area larger than all of the modern Great Lakes combined. Its shores were bound by ice walls and glacial ridges, its depths fed by torrents of meltwater streaming from the retreating Laurentide ice sheet. For thousands of years, the ice held firm, acting as a dam. But ice is never eternal, and in a warming world, cracks began to form. At some point near the beginning of the Younger Dryas, this immense storehouse of fresh water was released in catastrophic fashion. The dam of ice gave way, and Lake Agassiz spilled across the land in a flood that reshaped continents. Water surged through river valleys, carving new channels and filling ancient basins. Vast floods thundered toward the oceans, delivering not trickles but torrents, volumes so immense that they may have changed the very balance of the planet's climate. The key to this hypothesis lies in the North Atlantic, where the ocean's great conveyor belt of currents carries heat across the globe. Normally, warm water flows northward, releasing its energy into the atmosphere before sinking as it cools and returning southward in a deep circulation that drives climate stability. But this system is fragile, dependent on the delicate mix of salt and temperature in the ocean. Too much fresh water poured into the Atlantic, and the balance would collapse. That is exactly what the floodwaters from Lake Agassiz may have done. Fresh water, lighter than salt water, spread across the surface of the North Atlantic, preventing the normal sinking of currents. This disruption, sometimes described as a choking of the ocean's heartbeat, would have stalled the conveyor belt. With warm water unable to reach the northern latitudes, the atmosphere cooled dramatically. Greenland, where the ice cores preserve the memory of these changes, recorded a staggering drop in temperature of nearly 10 degrees Celsius within a human lifetime. The Great Flood hypothesis paints a picture of cascading consequences. A single glacial lake, emptied in a geological instant, may have plunged the entire planet back into cold. This would explain not only the suddenness of the Younger Dryas, but also its duration. Once the conveyor belt was disrupted, it may have taken centuries to restart, leaving the Earth locked in a prolonged freeze until the ocean's rhythm recovered. Geological evidence lends weight to this idea. Across the landscapes of North America, scientists have traced the scars of massive floods, channels gouged deep into the land, spillways that once carried unimaginable volumes of water, and layers of sediment spread across plains. In some regions, giant boulders lie scattered far from their source, transported by rushing torrents that no ordinary river could explain. In the North Atlantic itself, cores of ocean mud reveal sudden pulses of fresh water, the chemical signatures of glacial melt washing into the sea. This hypothesis also accounts for the global ripple effects seen in regions far from the Atlantic. When the conveyor belt stalled, it was not just Europe and North America that grew cold. Africa experienced severe droughts as rainfall patterns shifted. Asia's monsoons weakened, leaving once fertile regions parched. South America's rainfall collapsed, altering river systems and stressing ecosystems. A single flood may have sent tremors across the world, tying distant regions together in a shared winter of hardship. Yet, like the comet theory, the Great Flood hypothesis is not without its uncertainties. The timing of Lake Agassiz's drainage events is still debated. Some evidence suggests massive floods occurred close to the start of the Younger Dryas, while other studies argue the outbursts came slightly before or after. The exact path of the floodwaters is also contested, with some researchers pointing toward routes into the Hudson Bay, others toward the Mississippi River, and still others toward eastern outlets that would have poured directly into the North Atlantic. Despite these questions, the image is powerful. A world already shifting from ice to warmth, suddenly plunged back into cold by the very waters of its own melting. If true, it shows how delicately balanced the Earth's climate can be, how a single event in one part of the world can reshape conditions everywhere. It reminds us that while fire from the sky is dramatic, water from the earth can be just as devastating, carrying the quiet strength to cool an entire planet. While theories of fire from the sky and floods of fresh water capture the imagination, another possibility lingers quietly in the background, drawn from the restless power beneath the earth itself. Volcanoes, ancient mountains of fire, have always had the ability to shape climates as well as landscapes. When they erupt, their force does not remain local. The ash and gases they release can rise high into the atmosphere, where they drift across continents and oceans, changing the way sunlight reaches the surface of the earth. The Younger Dryas, with its sudden return to cold, has invited scientists to ask whether volcanic activity may have played a role. Though the evidence is not as strong as for floods or cosmic impacts, the idea deserves attention, for volcanoes have left their mark many times throughout history. When a great eruption occurs, the most significant effect is not always the lava that spills down slopes or the ash that falls nearby. It is the aerosols, tiny droplets of sulfuric acid and other particles, injected into the stratosphere. Once in that high layer of the atmosphere, these aerosols can linger for years, reflecting sunlight back into space. The effect is subtle at first, like pulling a thin veil across the sun. But as the veil thickens, the world beneath cools. Crops fail, seasons shorten, and ecosystems strain under the chill. In modern times, eruptions such as Mount Tambora in the year 1815 or Mount Pinatubo in 1991 have shown how quickly global temperatures can dip when the sky is filled with volcanic haze. Applied to the Younger Dryas, this theory suggests that one or several eruptions could have unleashed enough aerosols to spark the onset of cooling. The initial dip in temperatures, magnified by feedback loops in the climate system, may have locked the world into a long freeze. Snow and ice reflect sunlight more effectively than soil or forest. As ice spread, it reflected yet more light, reinforcing the chill. What began as a temporary effect could have cascaded into a much longer one. Some studies have looked for traces of volcanic material in ice cores drilled from Greenland, where the yearly layers preserve tiny bits of dust and ash carried on the wind. Indeed, volcanic signatures are present, faint markers of eruptions that occurred around the start of the Younger Dryas. These findings suggest that volcanoes may have contributed to the complex chain of events that sent the planet back into winter. Yet the volcanic hypothesis faces challenges. The known eruptions of that time, while significant, do not appear large enough to explain 1,200 years of cooling on their own. Volcanic effects are typically short-lived, lasting a few years or decades, not centuries. For volcanoes to have played the central role, they would have needed to erupt in repeated succession, keeping the skies hazy for generations. The geological evidence does not yet show such a sustained sequence. Still, the possibility that volcanoes acted as triggers or amplifiers cannot be dismissed. In a system as delicately balanced as Earth's climate, even a modest eruption could have tipped conditions already leaning toward instability. If the oceans were near a threshold, or if melting ice had already begun to reshape landscapes, then a veil of aerosols could have been the final push. Once the cycle of ice growth and cooling began, it might have been able to sustain itself far longer than the original volcanic effects. There is a poetic weight in considering volcanoes as part of this mystery. They are the voice of the Earth's deep interior, sudden outbursts from chambers of molten rock hidden far below. Their eruptions remind us that the planet is alive beneath our feet and that its movements can alter the course of life above. During the Younger Dryas, even if volcanoes did not serve as the primary cause, their shadows may have deepened the chill, leaving imprints that blended with other forces to create the cold that reshaped history. Volcanoes also leave behind more than ash. They etch their presence into rock, build mountains, and scatter minerals across landscapes. Their gases change the chemistry of air and water. In the Younger Dryas, these impacts may have layered onto floods and other events, weaving a complex tapestry of causes. Science rarely finds a single thread to explain everything. More often, it is a weaving of many strands, each contributing in its own way. In this light, the volcanic hypothesis serves as a reminder of complexity. The world is rarely shifted by only one event. Instead, it is nudged, pressed, and reshaped by many hands, some visible, some hidden. Volcanoes, with their clouds of ash and curtains of aerosol, may have been one of those quiet hands during the Younger Dryas, adding their shadows to the long winter that followed. Far beneath the frozen surface of Greenland lies a diary of the earth. It is not written in ink or carved in stone, but layered in snow that has fallen, compressed, and preserved over tens of thousands of years. Each winter leaves a new page, a thin sheet of white, and each summer leaves another, slightly different in texture and chemistry. As the weight of the ice builds, These pages press together, but they do not vanish. Instead, they are locked deep within glaciers, waiting for scientists to read them. Ice cores, extracted in long cylinders from these frozen layers, serve as time machines. They allow us to step back through millennia, year by year, breath by breath of ancient air. Each bubble trapped within the ice is a capsule of the atmosphere as it once was. Each particle of dust is a marker of winds and climates that blew across continents. To hold a section of ice core is to hold a fragment of the past, one that speaks softly but clearly of how the Earth once lived. When researchers drilled into the ice of Greenland, they uncovered evidence that stunned the scientific world. The record did not show slow, gentle shifts. It showed sudden leaps, as if the climate had stumbled and fallen in an instant. Around 12,900 years ago, just as humans began to settle and dream of farming, the ice revealed an abrupt plunge in temperatures. Within the space of only a few decades, Greenland cooled by as much as 10 degrees Celsius. The change was not gradual, like the passing of one season into another. It was swift and severe, written like a sharp line in the layered ice. This discovery confirmed what other clues had suggested. The Younger Dryas was not just a continuation of the Ice Age, but a dramatic interruption, a sudden detour into cold. The precision of the ice allowed scientists to see the event in fine detail, not in centuries, but in years. They could tell when the warming had stopped, when the cooling had begun, and when the cold had eventually ended 1,200 years later. The ice recorded both the beginning and the end of the Younger Dryas as abrupt shifts, sudden as the turning of a page. The chemistry of these layers tells a story in multiple voices. Isotopes of oxygen and hydrogen in the ice reveal temperatures, showing when warmth prevailed and when cold returned. Trapped air bubbles preserve greenhouse gases such as carbon dioxide and methane, offering a measure of the planet's breath. Dust blown across continents, carried by winds, became trapped in the snow, marking times when landscapes were dry and storms were frequent. Even volcanic ash appears here, tiny shards of glass that testify to eruptions that darkened skies thousands of miles away. From these combined clues, the Younger Dryas emerges as one of the sharpest climate shocks in Earth's history. The ice does not simply confirm that it happened, it reveals how quickly it happened. For people and animals living through it, the change would have been almost unimaginable. A child born into a warming world of growing forests could grow old in a landscape of tundra and ice. Generations would have lived and died under skies far colder than their ancestors had known, and then, just as suddenly, the warmth returned. The end of the Younger Dryas, too, is written in the ice. Around 11,700 years ago, the record shows another rapid shift, this time back toward warmth. Temperatures rose within only a few decades, glaciers retreated, and the Earth stepped into the Holocene, the warm and stable epoch that continues today. Once again, the transition was sharp, like a switch flipped in the planet's climate system. The ice makes clear that these were not gentle slopes but steep cliffs, changes that happened far faster than anyone had once believed possible. The beauty of the ice record lies not only in what it reveals, but in how it reminds us of the fragility of balance. Each layer, delicate and silent, carries within it the whispers of storms, the breath of ancient air, and the memory of seasons long past. Together, they show that the Earth's climate has always been capable of abrupt shifts, tipping points that arrive with little warning and reshape the future in a single human lifetime. The Greenland ice cores remain one of the most important archives of our planet's history. They have given scientists the clearest window into the Younger Dryas, showing the precision of its onset and its end, and confirming that this sudden freeze was not myth or speculation, but a real event written into the very fabric of the Earth's frozen memory. Beneath the calm surface of lakes, time settles quietly, grain by grain. Every year, as seasons pass, particles drift down into the still waters. Dust carried by winds, pollen released by forests, ash from distant fires, and even microscopic shells of tiny organisms all sink slowly through the water until they rest on the bottom. Layer after layer, year after year, the lake becomes a silent diary of the world above. Unlike rivers that rush and erase their own histories, lakes preserve, they record, they wait. When scientists drill into the mud beneath ancient lakes, they recover cores of sediment that act much like the pages of the Greenland ice. Each layer can be studied, revealing the fingerprints of ecosystems as they rose and fell, the signals of fires as they swept across the land, and the dust of faraway climates carried into the basin by wind. These lake sediments have become one of the most powerful ways to see what the Younger Dryas did to the world, not just in Greenland, but across continents. One of the clearest voices in these diaries comes from pollen. Plants release billions of grains each year, invisible to the eye, drifting in the air until they settle on the land or the water. Once trapped in the mud at the bottom of a lake, they remain perfectly preserved. By counting and identifying these tiny grains, scientists can reconstruct entire landscapes long vanished. When forests dominated, the layers are rich with the pollen of trees. When the cold pushed forests back, those layers vanish, replaced by the pollen of tundra plants like grasses and hardy flowers. During the Younger Dryas, these pollen records tell the same story again and again. Across Europe, forests that had begun to spread retreated almost instantly. Oaks, birches, and pines gave way to open tundra. In North America, the same pattern appears. Plants that thrived in warmth declined, replaced by species suited to cold and dry conditions. It was as if the clock of ecosystems had been wound backwards, erasing centuries of progress in only a few decades. Alongside pollen, charcoal appears in these sediments, the blackened remains of wildfires that burned across landscapes. Fires leave behind invisible smoke that drifts into lakes, and over time, those traces build up into dark bands within the sediment. During the Younger Dryas, spikes of charcoal appear in cores from North America and Europe. They may reflect vast fires that swept through drying forests and grasslands, perhaps triggered by lightning or even by cosmic events. Whatever their cause, they mark the stress of ecosystems breaking apart, the flames of collapse leaving their soot for lakes to remember. The lakes do more than tell local stories. What makes them so powerful is how they synchronize across vast distances. In North America, lakes from the Great Plains to the eastern forests all record the same abrupt shift. In Europe, from Ireland to Scandinavia, the story is mirrored. Southward too, into the Mediterranean, sediments reflect the same turning point. The records align not by chance, but because the climate itself shifted globally. The Younger Dryas was not a regional cold snap. It was a planetary event, its fingerprints pressed into every quiet basin of mud. The detail of these lake diaries is remarkable. In some cases, sediments capture changes year by year, showing not only that the climate grew colder, but exactly how plants and animals responded. For example, in one lake core, the pollen of trees declined so sharply that within only a handful of years, entire forests appear to have vanished from the region. This suddenness echoes the ice core evidence, reinforcing that the Younger Dryas was not a slow drift, but a rapid descent into cold. Tiny fossils of algae and microorganisms add yet another voice to the story. Their shells, made of silica or calcium, record changes in water chemistry. When climates grew colder and drier, lakes often became shallower or more alkaline. The types of algae shifted, leaving behind microscopic proof of broader climate stress. In some cores, the combination of pollen, charcoal, and microscopic fossils paints a vivid picture of ecosystems collapsing and rebuilding in real time. Taken together, these sediments show the Younger Dryas as a global synchrony. It was not just Greenland that froze suddenly. It was not just North America or Europe. Across continents, lakes tell the same tale: warmth rising, hopes building, then a sudden halt, a plunge into cold, and ecosystems unraveling. The silence of lakes became the voice of Earth's climate, whispering its secrets in grains of mud and flecks of pollen. The power of these records lies in their stillness. Lakes do not move as rivers do. Their calm waters patiently gather the traces of every season, never forgetting. For humans living through the Younger Dryas, these changes must have felt chaotic, unpredictable, even cruel. But in the sediments, the chaos resolves into patterns, clear and steady. The lakes kept watch, and in their mud, they preserved the memory of a world in shock. As the Younger Dryas settled into its long grip, the earth revealed its change not only in the air or in the shortening of seasons, but in the return of the great ice itself. Glaciers, which had been in retreat for thousands of years, slowed, paused, and then crept forward once again. Their advance was not as massive as during the peak of the Ice Age, but it was enough to scar landscapes and leave behind physical reminders that can still be traced today. In Scandinavia, frozen tongues of ice thickened and began pushing outward, inch by inch. Valleys that had once been clearing of snow were again pressed by walls of ice. Mountains bore the weight of frozen rivers, grinding their flanks. Rock faces cracked and split under the strain, and boulders were swept up and carried in the ice's relentless crawl. When the glaciers paused, they dropped their loads, leaving ridges of stone and clay, called moraines, behind them. These ridges remain today, marking with precision the limits of the Younger Dryas advance, as if the glaciers had signed their names across the landscape. The same story unfolded across the northern reaches of North America. The Laurentide ice sheet, already diminished from its Ice Age height, gathered strength again. In regions around the Great Lakes, its edges thickened and surged. Here, too, new moraines formed, long arcs of rock and sediment laid down as the ice pressed forward. To walk across one of these ridges now is to walk along the ancient front line of a temporary but powerful return to cold. The work of glaciers is both violent and quiet. They move slowly, often imperceptibly within the span of a human life, yet the changes they leave are vast. During the Younger Dryas, their grinding weight deepened valleys, redirected rivers, and scoured soil from bedrock. Entire landscapes were reshaped in silence. A smooth rock face, polished to a shine, or a field of boulders scattered hundreds of miles from their original homes are the silent signatures of this frozen advance. In some places, lakes formed where glaciers had blocked valleys, their meltwater spilling into new channels once the ice relented. Elsewhere, rivers that had carved steady paths for centuries were forced aside, creating new courses that would persist long after the glaciers withdrew. The land was in motion, not in the swift violence of storms or floods, but in the slow, grinding force of ice that carried mountains on its back. For the people who lived within sight of these ice fronts, the spectacle would have been awe-inspiring and unsettling. To see a wall of blue-white ice pressing forward where green valleys had begun to emerge only decades earlier, must have felt like the earth itself was changing its mind. Hunting grounds and river valleys were cut off, swallowed under frozen tongues. Camps and pathways that had served families for generations disappeared beneath the advance. While humans adjusted and moved elsewhere, the glaciers carved steadily, indifferent to the lives lived at their edges. Geologists have pieced together this icy return with remarkable clarity. By studying the moraines and sediments scattered across northern landscapes, they can map exactly how far the ice returned during the Younger Dryas. In southern Sweden and Norway, lines of moraine trace the edges of the Scandinavian ice sheet. Around the Great Lakes, moraines describe arcs that tell of the Laurentide's brief resurgence. These features are not subtle. They rise as ridges and hills across the land, their presence a reminder that ice once stood here, stubborn and powerful, before yielding again to warmth. What makes these geological traces especially striking is the speed of their creation. Normally, glaciers are thought of as symbols of slow change, advancing or retreating over thousands of years. But in the Younger Dryas, they responded within decades, a reminder that even ice can shift direction on a human timescale when climate is thrown into chaos. This ability to move quickly, to halt retreat and reclaim land, shows the sensitivity of glaciers to even small changes in temperature and precipitation. The scars left behind remain etched into the earth. Long after the Younger Dryas ended and the Holocene warmth returned for good, the moraines, the smoothed rock faces, and the altered valleys stood as enduring records. Today, hikers cross their ridges without always knowing they are walking atop the frozen footprints of ancient ice. Lakes sparkle in basins carved by glaciers that briefly surged during that 1,200-year winter. Every groove and ridge tells the story of that abrupt pause in Earth's warming when the planet nearly surrendered to a longer age of cold. The glaciers that reclaimed the land during the Younger Dryas would not endure. When the event ended, warmth surged back, and the ice resumed its final retreat. Yet the land still bears its testimony, a landscape marked by ridges, boulders, and valleys carved deeper than before. These scars remain as geological monuments, evidence that the cold was not only felt in the air, but written into stone. The Younger Dryas was not simply a northern chill. It was a ripple that spread across the globe, bending weather systems, shifting rainfall, and redrawing the map of life in ways that reached far beyond the edges of the ice sheets. While Greenland and North America froze, other regions suffered in silence, parched and cracked under skies that withheld rain. In Africa, ancient lakes that had once stretched across vast basins began to shrink. Before the Younger Dryas, North Africa was not the endless desert we see today. It was dotted with grasslands, rivers, and lakes large enough to rival seas. Lake Victoria, Lake Chad, and countless smaller basins had been swollen with meltwater and seasonal rains. These waters fed herds of antelope, supported fish, and nurtured the early human groups that gathered along their shores. But as the global circulation faltered, the rains grew weaker. The monsoon systems that carried moisture from the oceans into the heart of Africa stumbled. Lakes retreated from their banks, shorelines contracted, and the once fertile regions became drier with each passing season. In cores taken from African lake beds, layers of sediment grow pale, stripped of the organic richness that comes with water and life. They tell of a climate that suddenly pulled back its generosity. Across Asia, the mighty monsoons that have long shaped civilizations faltered as well. These monsoon rains are driven by the contrast between land and sea, by the seasonal dance of heat and pressure. When the global climate system shifts, the monsoon can weaken or fail entirely. During the Younger Dryas, this is exactly what happened. Regions of India, China, and Southeast Asia that had once been drenched each summer fell into drought. Rivers shrank, crops and wild plants struggled, and the rhythm of life tied to rainfall was disrupted. For the communities of hunter gatherers spread across these lands, the weakening of the monsoon was a silent but devastating blow, stripping food sources and forcing new migrations. In South America, the story was equally dramatic. The Amazon basin, now one of the wettest places on Earth, saw rainfall collapse in some regions. Sediment cores from lakes and caves reveal that parts of South America became much drier, with forests thinning and rivers contracting. The weakening of the intertropical convergence zone, the band of storms that circles the equator, played a role in this. As the Atlantic circulation faltered, the entire system of tropical rainfall shifted southward, leaving parts of the Amazon and the Andes starved of water. Ancient cave stalagmites, which grow layer by layer as water drips from above, record these changes in their chemistry, each band a memory of wetter or drier times. During the Younger Dryas, the stalagmites speak of drought, a message carved in stone by the slow dripping of water that nearly ceased. The pattern of these changes across Africa, Asia, and South America shows that the Younger Dryas was not simply a local cold snap locked in the northern latitudes. It was global. Ocean currents slowed or stopped, heat was redistributed, and the climate machine that ties continents together faltered. The drought in Africa was connected to the failed monsoons in Asia, and both were linked to the collapse of rainfall in South America. It was a chain of cause and effect, stretching across hemispheres, a reminder that no region exists in isolation when the Earth's systems shift. For early humans living through these events, the consequences were profound. In Africa, shrinking lakes meant fewer fish and waterfowl, fewer animals gathering at the water's edge to hunt. In Asia, weaker monsoons reduced the harvest of wild grains and fruits, forcing groups to move in search of more reliable lands. In South America, the contraction of forests may have reduced the diversity of plants and animals available to gather and hunt. Across continents, scarcity deepened, and survival meant adaptation in ways that shaped human history long after the Younger Dryas ended. The evidence for these global ripple effects comes not only from lakes and caves, but also from dust blown across deserts, trapped in ice cores thousands of miles away. During the Younger Dryas, dust from the Sahara increased dramatically, carried on winds into the Atlantic, and deposited in Greenland. This told scientists that Africa had dried severely, its soils left bare and exposed. At the same time, sediments from Asian lakes and stalagmites from South American caves revealed the same signal: dryness, disruption, decline. When viewed together, these records create a portrait of a planet connected by invisible threads. A flood in North America or a shift in the Atlantic could alter rainfall in Africa, monsoons in Asia, and the fate of forests in South America. The Younger Dryas, though most visible in the icy north, reached into the tropics and beyond, leaving no corner untouched. In its reach, the Younger Dryas stands as one of the clearest examples of Earth's interconnectedness. It shows how fragile the balance is, how quickly climates can tip, and how the effects of change can span continents in only a few years. The Younger Dryas pressed humanity to its limits. Across continents, the climate turned against the fragile progress that had begun during the warming years. Villages that had been taking shape were abandoned, fields that might have become farms lay barren, and groups of people were forced to scatter once again. Yet the story of this time is not only one of loss, it is also a story of resilience, of how small bands of hunter gatherers found ways to endure, drawing on ingenuity and cooperation to survive in a world that seemed determined to push them back into hardship. Archaeological evidence offers glimpses of how people met the cold. In regions of Europe, stone tools changed shape and design. Where once broad blades and sickle like edges had been crafted for harvesting plants, new tools emerged, sharper and more specialized for hunting smaller animals or cutting through frozen hides. Bone and antler were shaped into barbed points, useful for fishing or spearing in icy rivers. The sudden change in available resources forced humans to adapt quickly, and the archaeological record shows they did not hesitate. Tools became lighter, more efficient, and more versatile, reflecting a life of constant movement and uncertainty. Shelter, too, had to evolve. In the warmer years just before the Younger Dryas, some communities had begun to build permanent or semi permanent homes, structures of stone and wood that could last through seasons. But when the cold returned, mobility once again became the key to survival. Archaeological sites reveal circular huts built from mammoth bones and hides, designed to be both sturdy and temporary. Elsewhere, caves were reused, not as places of ritual or art, as in earlier times, but as practical refuges from the wind and snow. Fires burned at their entrances, and the walls bear the marks of smoke from long nights when families huddled inside, waiting for the storm to pass. Food strategies shifted with the land. Large animals, already in decline, became scarce. Mammoths, giant sloths, and other great beasts were no longer reliable prey. Hunters turned to smaller game, stalking reindeer, rabbits, and wild birds. Fishing became more important, with hooks carved from bone and nets woven from plant fibers, providing steady catches where rivers still ran. Gathering of roots, nuts, and hardy plants supplemented diets, though the cold shortened growing seasons and reduced abundance. Every scrap of food had to be used, every hunt had to succeed, and every wasteful mistake could mean hunger. The resilience of these small groups is remarkable. In North America, where the Clovis culture had faded, new traditions emerged. The people who followed crafted different spear points, adapted for the animals still present. In the Levant, the Natufians who had once dreamed of settled villages adapted by becoming mobile again, their grinding stones and storage pits abandoned in favor of lighter, more portable tools. Across the world, survival depended on flexibility, on the ability to let go of old ways and embrace new ones. What carried humans through this time was not just the tools in their hands, but the bonds they shared. Archaeological evidence points to cooperation. Burials show communities caring for the weak and the injured. Injuries that would have been fatal without assistance show signs of healing, suggesting that even in times of scarcity, people shared food and shelter. The survival of humanity was not only a matter of skill but of compassion, of working together to endure conditions that no individual could face alone. Innovation became the lifeline. Clothing was sewn from furs and hides, stitched with bone needles to hold tight against the wind. Weapons were refined for efficiency, conserving energy in a time when every effort mattered. Fire was managed with greater care, not only for warmth but for cooking, preserving, and keeping predators at bay. Even the way people organized their days shifted. Camps were set near water sources, with careful planning for when rivers froze or animals migrated. These adaptations show the remarkable ability of humans to bend without breaking. While many species could not adjust to the sudden cold, humans found ways to endure. They did not flourish in the Younger Dryas, but they survived, carrying their knowledge forward into the warmer Holocene. That survival was not guaranteed. Populations declined, migrations scattered, groups and some cultural traditions disappeared forever. But the thread of humanity remained unbroken, stretched thin yet strong enough to hold. The Younger Dryas was a trial by ice, a reminder that progress is never certain. It nearly erased the first steps toward farming. It ended the great traditions of mammoth hunters, and it forced humans back into the life of constant adaptation. Yet within that struggle lay the seeds of resilience. Innovation in tools, shelters, and strategies ensured that when the cold finally lifted, humanity would be ready not just to survive, but to build again. Long before the first words were etched into clay or stone, human memory lived in stories. Around fires, beneath open skies, people spoke of floods, of fire, of sudden cold, and of worlds remade. These tales carried on the breath of elders to children, and then from children to their own children, stretched across centuries. Today, scientists listen closely to these ancient voices, wondering if behind the myths there may be echoes of real events, whispers of the Younger Dryas, written not in books, but in memory. In the Fertile Crescent of Mesopotamia, one of the world's oldest written stories tells of a great flood. The Epic of Gilgamesh, first inscribed more than 4,000 years ago, describes waters rising so high they swallowed mountains. It speaks of boats built in desperation, animals gathered two by two, and a world cleansed by sudden catastrophe. The story has long been compared with the later tale of Noah's Ark, yet both may reflect something even older. Some scholars suggest they preserve distant memories of ancient floods, perhaps the great torrents released when glacial lakes burst their icy walls at the end of the Ice Age. Across the vast Pacific, oral traditions of Native American peoples speak of waters that came without warning. In the lands along the Pacific Northwest, tales describe ocean waves rushing inland, swallowing forests and scattering communities. In the Mississippi Valley, some tribes remember a time when the rivers rose in fury, changing their courses and leaving behind vast plains. Such floods might have been linked to the colossal outpourings from glacial Lake Agassiz, which sent fresh water surging across continents and into the Atlantic Ocean, disrupting currents and climate alike. Though these events unfolded more than 12,000 years ago, they were so dramatic that their memory may have imprinted itself into the very fabric of culture. Further north, Inuit traditions describe long ages of ice and sudden changes in climate. Stories tell of times when the air grew harsh and the hunting grounds shifted, forcing families to move or perish. In these tales, animals often speak or guide, hinting not only at the struggle for survival, but also at the respect and reverence people felt for the creatures that endured alongside them. These narratives may contain reflections of real ecological shifts during the Younger Dryas, when prey animals dwindled and humans were pushed to adapt or vanish. Even in South America, myths of deluges and collapsing skies echo through Andean and Amazonian traditions. Some recount times when the sun vanished, leaving the world in darkness and cold, while rains and floods reshaped the land. These may be distant memories of sudden droughts, followed by flooding rains, as climate systems faltered during that thousand-year chill. Oral traditions tend to transform such events into symbolic stories, yet within the symbols lie clues. The collapse of monsoons in Asia, the retreat of forests, and the drying of great lakes in Africa are mirrored by the universality of myths that speak of disruption and renewal. The Younger Dryas was not merely a scientific event recorded in ice and stone. For the people who lived through it, it was lived reality, and reality becomes story. Fireside tales were not idle amusements. They were instructions, warnings, and ways of keeping collective memory alive. A flood remembered in myth might have served as a lesson for descendants. Build high, be prepared, respect the waters. A story of endless winter might have been told to remind children of the fragility of warmth and the importance of cooperation. Scientists tread carefully when comparing mythology to climate history, yet the parallels are striking. The sudden collapse of warming, the floods from glacial lakes, the shifts in seasons and food, all of these could have left impressions strong enough to echo for thousands of years. Myth is not literal history, yet it may be a kind of fossilized memory, reshaped through generations until its origins blur, but its heart remains intact. This blending of science and memory reminds us that data does not only rest in ice cores or sediments, it also lingers in words, in symbols, in stories that survived where villages and cultures did not. A tale told in Mesopotamia, another on the plains of North America, and yet another in the mountains of South America may all carry faint reflections of the same ancient upheaval. For those who endured the Younger Dryas, the world itself became a storyteller, shaping the myths that guided generations long after the ice retreated. Roughly 11,700 years ago, the deep freeze that had gripped Earth began to loosen its hold. What makes this moment so extraordinary is how quickly it unfolded. For more than 1,000 years, much of the world had known nothing but bitter cold. Glaciers crept forward, tundra spread across continents, and survival was a daily trial for both humans and animals. Yet, almost as suddenly as the Younger Dryas had arrived, it came to an end. Temperatures rose not over millennia, but within the span of decades. In Greenland, ice cores reveal this astonishing transition with razor-sharp clarity. The chemical fingerprints of ancient air, trapped inside layers of snow that hardened into ice, show a sudden leap in temperature. Within the lifetime of a single human, the climate shifted from punishing cold to warmth. Where tundra flowers had stretched across Europe and North America, forests began to return. Where frozen rivers had once stopped flowing, waters rushed again, carving their way through valleys. The key to this abrupt warming may have rested in the oceans. For centuries, the great conveyor belt of currents that moves heat around the globe had been disrupted, choked by floods of fresh water pouring into the North Atlantic. Without the dense, salty water sinking into the deep ocean, the system had faltered, leaving vast regions locked in winter. Then, as if some unseen switch had been thrown, circulation restarted. Salty waters once again plunged into the depths, pulling warm currents northward, breathing heat back into the climate. The effects rippled outward with astonishing speed. Monsoons that had faltered returned to Asia, reviving once parched lands. In Africa, great lakes that had shrunk in the cold began to swell once again. Across South America, rainfall patterns shifted, bringing rivers back to life. Entire ecosystems, once pressed into silence by the cold, erupted in a renewed chorus of growth. For humans, this transformation was both a relief and a challenge. Generations had adapted to the hardships of a frozen world. They had followed herds across icy plains, scraped out livings from meager resources, and endured bitter winds that made each day uncertain. Now, suddenly, the rules had changed. The cold that had demanded resilience was gone, replaced by warmth and abundance. Grasses grew taller, forests spread wider, and rivers carried fish and waterfowl in numbers not seen for centuries. In the Fertile Crescent, this return of warmth brought with it fertile soil, steady water, and a long growing season. For communities that had once experimented with harvesting wild grains, conditions were now perfect for a leap forward. The seeds of agriculture, interrupted by the Younger Dryas freeze, began to take root in earnest. Villages could form where food could be stored, harvests planned, and people no longer forced to move with every season. In Europe, the retreat of ice reshaped landscapes with startling speed. Glaciers that had clawed across valleys melted back, leaving behind scarred stone and new rivers that cut across plains. Animals once pushed to the brink of extinction began to recover in some regions, though many, like the mammoth and the saber-toothed cat, had already vanished forever. Those that endured, such as bison and reindeer, found new grazing grounds, and human hunters adjusted to their patterns. The end of the Younger Dryas marked more than the close of a chapter. It signaled the final end of the Ice Age. For more than 2 million years, Earth had cycled through periods of ice and warmth. Enormous glaciers had grown and shrunk, reshaping continents, steering evolution, and determining where humans and animals could survive. But now the curtain was falling on this ancient rhythm. The Holocene had begun, a new epoch defined by a climate more stable than almost any that had come before. It is difficult to overstate the suddenness of this shift. Imagine being born into a world of snow and ice, where summers never truly came, where food was scarce, and every day was a test of endurance. Then, within your lifetime, the world softened. Trees returned where there had only been frozen scrub, rivers widened, game became plentiful. For the first time in human history, the environment allowed not just survival but growth, settlement, and civilization. The sudden return of warmth was not gentle everywhere. Floodwaters roared as glaciers melted at a pace unseen in thousands of years. Seas rose quickly, swallowing coasts and reshaping shorelines once again. Some of the land bridges that had allowed ancient migrations, such as the connection between Asia and the Americas, disappeared beneath the waves. For those living near the water's edge, this would have been as catastrophic as the freeze itself, displacing families and forcing migrations. Yet out of this upheaval, humanity found opportunity. The return of warmth was a gift, and with it came the conditions that allowed culture, farming, and villages to flourish. The Younger Dryas had nearly erased that possibility, holding humanity in winter's grasp. Its abrupt end unlocked the world that would become our own. When the long winter of the Younger Dryas finally gave way, the world entered a gentler rhythm. The sudden return of warmth unlocked landscapes that had been frozen for centuries. Glaciers that once held back rivers melted into streams that fanned across valleys. Fertile soil, enriched by centuries of ice grinding stone into fine dust, was left exposed to sun and rain. It was as though the earth itself was offering a fresh beginning. For the people of the Fertile Crescent, a region stretching through parts of modern-day Iraq, Syria, Israel, and Turkey, this change was nothing short of transformative. Here, wild stands of wheat and barley already grew in abundance, nourished by the rich soils of the valleys and the dependable waters of the Tigris, Euphrates, and Jordan. During the long, Younger Dryas freeze, people had experimented with gathering these grains, storing them, and even planting seeds in small patches. But the cold had kept farming from becoming reliable. When the warmth returned, those experiments flourished into something new. Archaeologists have found evidence that in this moment, humanity began to cross a threshold. The Natufian culture, which had nearly collapsed during the cold, now surged back with renewed energy. Villages began to appear in fertile valleys, their houses built from stone and clay. Storage pits were dug to keep harvests safe from pests and seasons. Grinding stones, worn smooth by countless hours of use, tell of people transforming raw seeds into flour. And the first sickle blades, made from stone set into wooden handles, reveal how fields of grain were deliberately cut and gathered. The transition was gradual, but unmistakable. For tens of thousands of years, people had followed herds, lived in temporary shelters, and moved with the seasons. Now, some began to linger in one place, season after season, tending crops they had sown, waiting for harvests they had planned. The seeds of civilization were quite literally being planted in the soil. The Fertile Crescent was not alone in this quiet revolution. In the Nile Valley of Africa, as waters stabilized after the melt of distant glaciers, communities found fertile ground for cultivating plants. In China, early signs of rice domestication began to appear in warm river valleys. In the Americas, wild squash and beans were gathered and tended. These first steps were small, scattered, and fragile, but together they marked a turning point in human history. The warmth of the Holocene provided a rare gift: stability. For the first time in generations, people could expect the seasons to follow a predictable path. Spring brought planting, summer ripened the crops, autumn allowed for harvest, and winter was endured with stored food. This pattern allowed communities to grow larger than ever before because they were no longer bound to the uncertainty of the hunt. With permanent settlements came profound changes in daily life. Houses were clustered together, and pathways wore into the earth as people moved between neighbors. Tasks began to specialize. Some gathered, others planted, while skilled hands shaped tools, baskets, and clothing. In these small villages, one can trace the faint outlines of social structures that would grow into the complex webs of future civilizations. Farming also changed the relationship between humans and the land itself. Where once wild grains grew in scattered stands, people now cleared fields and deliberately sowed seeds. Generation by generation, plants that thrived under human care became more dependent on it. Wild wheat, for instance, shattered easily to scatter its seeds, but domesticated varieties held together until harvested. This gradual process of selection, carried out without written plans or conscious design, laid the foundation for domesticated crops that still feed the world today. Animals, too, were drawn into this new partnership. Dogs had already been companions and helpers in the hunt, but now sheep, goats, and later cattle began to be kept near villages. Their milk, meat, hides, and even their strength for labor deepened the bond between people and their environment. The great roaming herds of the Ice Age were disappearing, yet humans were beginning to shape new kinds of abundance. The quiet revolution of agriculture did more than provide food, it reshaped time itself. Hunter-gatherers had lived by the rhythm of migration, but farmers lived by the rhythm of the seasons. Fields demanded attention, and harvests demanded planning. Life became tied to the land, measured by the cycles of growth and rest. This deepened connection to place gave rise to new forms of culture, new ways of thinking, and eventually, the first written records. Archaeological sites from this period reveal not just tools, but also art and ritual. Carved figurines, decorated vessels, and communal gathering spaces hint that farming communities were not only building villages, but also shared identities. Rituals tied to planting and harvest may have been among the earliest ceremonies linking humans to the cycles of the earth in symbolic ways. The shift from wandering to staying brought challenges too. Farming demanded labor and carried risks. A failed harvest could mean hunger, and stored food attracted pests and disease. Yet for many, the benefits outweighed the risks. With farming came security, the possibility of surplus, and the ability to support larger families. Populations grew, and with them, the potential for culture, innovation, and eventually, the rise of the first cities From scattered villages along the Fertile Crescent to distant valleys in Asia and Africa, the seeds of civilization were taking root. Humanity, once shaped entirely by the movements of ice, animals, and climate, was now beginning to shape the world in return. The Younger Dryas had nearly erased the chance for such a future, but with its end, a new story began, one written not in ice or stone, but in fields of wheat and barley swaying beneath the warming sun. The great freeze of the Younger Dryas ended as abruptly as it began. Around 11,700 years ago, the chill that had held the world in its grip began to melt away. The transformation was astonishingly swift. Ice core records from Greenland reveal that in only a handful of decades, temperatures rose by nearly 10 degrees Celsius. To a human living at the time, the change would have been unmistakable. A generation could grow up watching winters grow milder, forests creeping back into once barren tundra, and rivers running longer before freezing. This sudden warmth marked the birth of the Holocene, the geological epoch that still enfolds us today. Unlike the chaotic swings of climate that had characterized the ice ages, the Holocene offered something rare: stability. For thousands of years to come, seasons would follow a gentler rhythm with fewer violent fluctuations. This new steadiness created a stage on which human history could unfold in ways that had never before been possible. The landscapes that emerged were strikingly different from those that came before. In northern Europe, pine and birch gave way to oak, elm, and hazel. Meadows blossomed where once only tundra had clung to the soil. In North America, vast plains filled with grasses supported herds of bison, while forests stretched across regions that had been scraped bare by glaciers. Lakes formed in the basins carved by ice sheets, their waters feeding rich ecosystems teeming with birds, fish, and mammals. The earth had become a canvas painted with green, and life responded eagerly to the opportunity. For humans, this warming was not merely a matter of comfort. It was a turning point that allowed people to move beyond survival into invention. Where the Younger Dryas had forced small bands of hunter-gatherers into desperate adaptation, the Holocene gave them room to grow. Villages began to take root more firmly. The seeds of agriculture, planted tentatively during earlier warm phases, now flourished. Farmers could rely on the seasons with a confidence that had been impossible in the unstable climates before. In the Fertile Crescent, fields of wheat and barley were carefully tended. In China, rice paddies began to take shape in the wetlands of the Yangtze River Valley. In Mesoamerica, early farmers nurtured squash, beans, and eventually maize. Across the world, in separate regions and at different times, people began turning wild plants into cultivated ones. This was not a single discovery, but a pattern repeated again and again as humans learned that they could coax the land to yield food. The ability to stay in one place changed everything. Villages became larger, with permanent houses built from stone, clay, or timber. Pottery was developed to store grain and carry water. With stored food came security, and with security came the possibility of larger families. Populations began to grow in ways that hunting and gathering alone could never have supported. With larger communities came new forms of social life. People organized themselves in ways that went beyond the family group. Leaders emerged, tasks were divided, and cooperation became more complex. In some settlements, archaeologists find evidence of communal buildings that may have served as gathering places for rituals or decision-making. These early social structures were the foundation stones of what would one day become towns, cities, and states. The The Holocene also saw the beginnings of domesticated animals becoming an integral part of human survival. Sheep and goats were herded in the highlands of the Middle East, while cattle became vital sources of both food and labor. Dogs, long companions of human hunters, adapted seamlessly into settled life, guarding homes and helping with herds. The partnership between humans and animals deepened, shaping not only diets but daily rhythms of life. One of the quiet revolutions of this age was the way time itself was measured. Farmers needed to know when to plant and when to harvest. The observation of seasons became critical, and so early calendars were born. Patterns in the stars and the movement of the sun across the horizon began to take on new meaning. Skywatching, once a way to navigate or mark the passing of days, became a tool for organizing the tasks of entire communities. The Holocene's stability also gave rise to culture in new forms. Art and ritual flourished, no longer pressed entirely to the margins by the demands of survival. Cave paintings continued to appear, but now so did carvings, pottery designs, and figurines that may have carried spiritual meaning. Burial sites from this era suggest growing complexity in beliefs about life and death, with goods placed beside the deceased as though for use in another world. While this new epoch offered stability, it did not erase the memory of what had come before. The suddenness of the Younger Dryas lingered like a warning in oral traditions and myths. Communities that had survived the long cold may have passed down stories of floods, fires, or winters that would not end. These stories, shaped by memory and retelling, remained part of the human imagination even as the earth seemed to promise gentler days ahead. In every way, the Holocene was the threshold of history. It gave humanity the stability to experiment, to gather in larger numbers, to dream further into the future. The great sweep of civilizations, from Mesopotamia to the Indus Valley, from the Nile to the Americas, would all rise on the foundation laid in these first centuries of warmth. The earth had shifted into a calmer state, and in that calm, humans would begin to build the intricate, fragile story of civilization itself. When the long cold of the Younger Dryas gripped the planet, many creatures could not endure. The woolly mammoths, saber-toothed cats, and giant ground sloths faded from the world, leaving behind frozen remains and silent bones, yet not all vanished. Some species endured, clinging to life through resilience, adaptability, or sheer luck. These survivors would carry their lineages into the warmer world of the Holocene, shaping the ecosystems and even the human cultures that followed. Among the most enduring were the great herds of bison, unlike mammoths, which required vast tracts of tundra and specific diets of grasses. Bison proved more flexible. They roamed the plains of North America in shifting numbers, grazing on a wide variety of plants. Their smaller size compared to mammoths gave them an advantage. They required less food and could move quickly to find new grazing grounds when one area failed. As the climate shifted, the bison adapted to both colder and warmer stretches, always keeping to the open lands where grasses could still thrive. Reindeer, or caribou as they are known in North America, were another testament to survival. Perfectly suited to harsh cold, they had wide hooves for walking across snow, thick coats for warmth, and the ability to feed on lichens that few other large animals could digest. This made them uniquely capable of enduring, even as tundra spread again during the Younger Dryas. Where mammoths starved, reindeer found food hidden beneath snow and ice. To human groups in the far north, reindeer became not only a source of food but also a vital partner in survival, offering hides for clothing and antlers for tools. Smaller animals, too, demonstrated remarkable endurance. Rabbits, rodents, and foxes adjusted their ranges as the environment shifted, their shorter breeding cycles, allowing them to adapt quickly to new conditions. Birds changed their migration routes, following patterns of food and climate. Even fish responded, with species like salmon continuing their ancient cycles, despite changes in river flow and ice cover. The story of the Younger Dryas is often told through its extinctions, but woven within it is the quieter tale of survival, where adaptability was often the difference between disappearance and endurance. Humans themselves were among the survivors, though not without difficulty. Archaeological evidence shows that populations shrank in many regions, and cultures like the Clovis in North America disappeared from the record. Yet scattered groups endured, finding new strategies when old ways failed. Some turned to smaller game when the great beasts vanished. Others learned to rely more heavily on fish, nuts, and seeds. Shelters were improved, clothing became more carefully crafted, and tools evolved to match the new reality. Genetic studies reveal that these centuries of struggle left an imprint still carried today. When populations dwindle, genetic diversity narrows, creating what scientists call a bottleneck. This happened not only to humans, but to many animal species that survived the Younger Dryas. In the DNA of modern people, faint signatures remain of this era, traces of reduced diversity that reflect the narrow thread by which our ancestors held on. Similar marks can be seen in surviving animals such as bison and reindeer, whose populations once dipped so low that they might have vanished entirely. Evolution leaves fingerprints in times of crisis. Traits that aided survival became more common, shaping the course of species long after the ice retreated. In humans, genes linked to metabolism and cold resistance may have been sharpened during this era. For animals, behaviors that allowed flexibility in diet or movement became vital. The creatures that endured were not always the strongest or the largest, but those best able to bend with the shifting winds of change. The survivors of the Younger Dryas not only carried life forward, but also formed the foundation of the ecosystems that would flourish in the Holocene. The plains of North America echoed with bison herds, shaping both the land and the cultures of people who would one day follow them. Reindeer remained central to the lifeways of Arctic peoples, their migrations setting the rhythm of human existence in the north. The smaller creatures, from birds to rodents, kept ecosystems intact, ensuring that when warmth returned, forests and grasslands could grow once again. For humans, the survival of certain species was more than a matter of biodiversity, it was a matter of companionship and reliance. Dogs, already partners in hunting, continued their close bond with people, offering protection and aid in finding food. Goats and sheep, adaptable and hardy, began their slow journey toward domestication. The animals that endured alongside humans became woven into the story of civilization itself. The Younger Dryas revealed that survival often hinges not on dominance, but on adaptability. Species that once seemed eternal, like the mammoth, could vanish in only a few generations. Others, smaller and less imposing, persisted through cleverness of design and flexibility of habit. Humans, caught in the same struggle, mirrored this lesson, altering tools, shelters, and ways of life to remain. The world that emerged at the end of the Younger Dryas was shaped as much by what survived as by what was lost. The scars of extinction marked the past, but the persistence of bison, reindeer, and countless smaller beings ensured that life continued to weave itself across the changing earth. The narrow passage of survival had been crossed, leaving behind a living legacy etched in genes, in landscapes, and in the enduring partnership between humans and the natural world. The Younger Dryas did not only leave its mark in the stories of people and the survival of animals, it carved its memory deep into the land itself, etching scars that can still be traced today. Across continents, stone, soil, and river valleys carry the fingerprints of a planet thrown into sudden turmoil. These landscapes speak a language of catastrophe, written not in words but in canyons, boulders, and flood carved plains. One of the most dramatic examples lies in the Pacific Northwest of North America. Here, the legacy of massive floods has shaped the ground into something both haunting and beautiful. At the height of the Ice Age, a great body of water called Glacial Lake Missoula formed when an ice dam blocked rivers in what is now Montana. When that dam failed, torrents of water roared across the land, tearing away soil, scouring rock, and cutting channels on a scale almost beyond imagination. Some researchers believe that repeated bursts of such floods occurred, and that during the Younger Dryas, the final surges may have reshaped the region once more. The land left behind is known today as the channeled scablands. These vast tracts of eroded ground stretch across eastern Washington state, marked by deep coulees, plunge pools, and giant ripples frozen in stone. To stand in those scablands now is to see emptiness on a monumental scale. Broad valleys that look like dried riverbeds, cliffs sheared smooth, and isolated buttes rising like islands in a vanished sea. It is a permanent reminder of floods so powerful that they scoured landscapes in mere days, floods that roared louder than any storm we can imagine today. Beyond North America, glaciers too left their record of the Younger Dryas return. In Scandinavia, ice sheets that had been retreating suddenly surged forward again. They ground across valleys, leaving behind fresh moraines, those ridges of rock and debris bulldozed into place by the slow crawl of ice. Each moraine is like a punctuation mark in the story of the Earth, a frozen record of when the ice advanced before finally pulling back. In places such as Norway and Finland, these moraines stand as winding ridges across the countryside, subtle reminders of how far the glaciers once reached during the cold relapse. In North America, glaciers also advanced again, clawing back land they had released. The Laurentide ice sheet, a colossal blanket of ice covering much of Canada, pushed forward into new ground, leaving its own moraines scattered across the landscape. Farmers plowing fields thousands of years later would strike against stones carried hundreds of miles by this ice, never knowing that the rocks beneath their feet were part of a story written during a sudden freeze. Even rivers and lakes across the world carry traces of this time. Ancient shorelines, cut into stone, reveal where waters once surged higher or fell lower as glaciers dammed and released them. In the Great Lakes region, shifting ice altered drainage patterns again and again, shaping the contours of the lakes as we know them now. Some valleys became overdeepened by ice and floods, filling later with lakes that still exist. The very geography of entire continents was resculpted in the Younger Dryas years. Geologists reading these scars see not just destruction, but also the testimony of speed. The Earth is often imagined as changing slowly in rhythms beyond human timescales, but the scablands, the moraines, and the sudden floods are proof that landscapes can be transformed in days or decades. Canyons miles wide, boulders the size of houses, and plains carved into ripples were not shaped over millions of years. They were born in violent bursts, triggered by ice and water released in moments of chaos. For the people of the time, these shifts would not have been abstract. Imagine a valley where generations had hunted and foraged, suddenly swallowed by floodwaters roaring faster than a horse could run. Imagine fields of grasses scraped away by advancing ice, or rivers that once fed fish and fresh water turning to torrents of ice-choked mud. Whole homelands could vanish in a season, and for those living at the edge of survival, the land itself must have seemed restless and dangerous, almost alive. Some of these scars remain so stark that they puzzled scientists for centuries. Early geologists looking at the scablands of Washington believed they must have been carved over millions of years by ordinary rivers. It was not until the 20th century that evidence finally revealed the truth, a flood so sudden and vast that it defied belief. The discovery reshaped not only our understanding of that region, but also our recognition of how abrupt events like the Younger Dryas can leave their marks on the earth. Even today, landscapes across the world hold similar puzzles. In South America, in Africa, and in Asia, valleys, lakes, and dry channels bear witness to sudden droughts and floods linked to shifting climates. Each is a reminder that the Younger Dryas was not a local crisis but a global one. The scars may differ in form, but they share a common origin: the instability of a planet caught in the grip of rapid change. These scars, preserved in stone and soil, are silent yet enduring storytellers. They remind us that the land we walk upon is not fixed, but shaped by forces far greater and swifter than we often imagine. To trace a moraine with your hand, to stand at the edge of a scoured coulee, or to look across the ripples of the scablands, is to see the memory of a world that once slid backward into ice, and to understand that Earth's history is written not just in ages, but in sudden, breathtaking moments of upheaval. Beneath our feet, hidden in soils and sediments, lies a line that scientists can follow like the trace of an ancient scar. It is not visible to the naked eye at first glance, but when examined closely, it reveals itself as a peculiar, thin horizon that appears in lake beds, peat bogs, and buried soils across continents. This layer marks the beginning of the Younger Dryas, the sudden cold snap that nearly turned the world back into ice. It is known simply as the Younger Dryas boundary layer. What makes this thin layer remarkable is what it contains. When scientists sift through the sediments, they find microscopic curiosities that do not match what came before or after. Mixed within the soil are tiny glassy spheres, minuscule diamonds, and fragments of charcoal. Each particle is a whisper of something extraordinary that happened more than 12,000 years ago, though the exact story they tell is still debated. The glassy spheres, known as spherules, are rounded droplets of melted material that hardened as they cooled. They form under intense heat, the kind produced by volcanic eruptions, lightning strikes, or the fiery entry of objects from space. To find them scattered across sites in North America, Europe, and beyond suggests that at the start of the Younger Dryas, something happened on a scale large enough to melt and scatter material far and wide. Then there are the nanodiamonds. These are diamonds so small that they cannot be seen without powerful microscopes. They are not the kind polished into jewelry, but tiny crystals born of pressure and heat. Scientists have found them in Greenland ice cores and in soil layers, dating exactly to the onset of the Younger Dryas. Their presence hints at a cataclysm, because such diamonds are thought to form in the shock waves of cosmic impacts when a comet or asteroid slams into Earth with unimaginable force. Charcoal also appears in this mysterious boundary layer. In site after site, thin dark bands of carbon suggest that fires burned across vast landscapes at the same time. Forests may have gone up in flames, prairies may have been scorched, and animals and people alike may have watched horizons glow red. The charred remains settled into sediments, creating a silent record of an age when fire followed cold. Taken together, these clues form a puzzle that has fascinated scientists for decades. One possibility is that a comet or fragments of a comet struck Earth, igniting wildfires and hurling dust into the atmosphere. This could explain the nanodiamonds, the spherules, and the sudden presence of widespread charcoal. Another possibility is that the evidence points to intense wildfires triggered by other forces, perhaps rapid climate shifts or volcanic activity. The debate remains unresolved, which is why the Younger Dryas boundary layer is often described as one of the strangest puzzles in the history of climate science. The intrigue lies not just in what the layer contains, but also in how consistent it is across the world. In North America, where mammoths and Clovis hunters once roamed, the layer is dark with charcoal and dotted with glassy spheres. In Europe, the same horizon carries microscopic evidence of disruption. Even in South America and the Middle East, traces of similar particles appear. It is as though a silent hand swept across the earth, leaving a faint signature in the dirt for future generations to discover. For archaeologists, this layer is a boundary in human history as well as natural history. Above it, evidence of some cultures vanishes. The Clovis culture in North America, famous for its finely crafted spear points, disappears from the record soon after this line appears. In the Levant, proto-farming communities collapse. The coincidence of cultural loss and geological change makes the boundary layer a line not only of science, but of human fate. The beauty of this puzzle is in its detail. Scientists study the spherules under microscopes, noting their smooth, glassy shells and internal structures. They analyze the nanodiamonds, marveling at how they could have formed in an instant of unimaginable force. They measure the thickness of charcoal bands, trying to estimate how much of the ancient world may have burned. Every fragment, no matter how small, is a clue pointing to a story that remains unfinished. The Younger Dryas boundary layer reminds us that Earth's history is not always gradual. Sometimes, entire epochs shift in the space of a generation, leaving behind subtle traces for future eyes to find. The layer itself is only a thin smear in the soil, often no thicker than a fingernail. Yet within it are the echoes of fire, ice, and possibly the fall of a comet. It is a fragile line, but also one of the most revealing. To hold a fragment of spherule in hand is to touch a moment when the planet itself may have convulsed. To study the nanodiamonds is to peer into conditions that exist only in the heart of impacts or explosions. To follow the charcoal is to imagine ancient forests set alight beneath an unfamiliar sky. The strange mixture of clues makes the boundary one of science's most enduring mysteries. Was it truly a cosmic visitor that struck Earth, or was it the planet itself shifting violently as glaciers melted and seas surged? The soil does not answer outright, only whispering its contradictions. Yet by tracing this thin horizon across continents, scientists continue to unravel how the Younger Dryas began and why it changed the world. The story of the Younger Dryas is not told in a single voice, nor revealed by a single discovery. It has been pieced together by countless hands and eyes, working across disciplines that seem far apart, yet overlap in their search for answers. To understand a sudden global freeze that happened more than 12,000 years ago, scientists have had to become detectives, each field carrying a different kind of magnifying glass. Climatology, archaeology, and geology form the heart of this investigation, but beyond them lie many more specialities, each adding its thread to the tapestry of a mystery still unfolding. Climatologists were among the first to suspect something extraordinary in the record of the past. By drilling deep into Greenland's ice sheets, they extracted cores that preserved bubbles of air older than civilization itself. These frozen cylinders became time machines, each layer corresponding to a year, sometimes to a season. Within them, concentrations of carbon dioxide, methane, and isotopes of oxygen revealed how temperatures rose and fell. When researchers reached the layers dating to the Younger Dryas, they saw something startling. In the space of only decades, temperatures had dropped by nearly 10 degrees Celsius. The ice did not lie. The climate had swung from warming to deep cold, then back again just as abruptly centuries later. Archaeologists, meanwhile, studied the traces of human life from the same era. In the Levant, they examined the remains of Natufian villages, once thriving on wild grains and early farming, only to see them collapse during the cold interval. In North America, they traced the stone points of the Clovis culture, only to find that soon after the onset of the Younger Dryas, the distinctive tools disappeared from the archaeological record. These abrupt cultural changes suggested that climate was not a distant force, but one that struck directly at the survival of people, reshaping their societies and forcing them into new ways of living. Geologists added their own pieces to the puzzle by reading the scars of landscapes. They walked the scablands of Washington, where giant floods had carved valleys as wide as cities. They traced moraines in Scandinavia and North America, ridges of rock left behind when glaciers advanced once more. They mapped layers of sediment in lakes and rivers that showed sudden influxes of dust, pollen shifts, and charcoal. The Earth's surface became their crime scene, and every stone and soil layer offered evidence of what had taken place when the world shivered into ice. The collaboration between these disciplines brought new energy to the mystery. A climatologist might point to a sudden drop in methane levels in an ice core, hinting at the collapse of wetlands. An archaeologist might show how human migration patterns shifted at the same time. A geologist might add that lake sediments recorded floods on a scale capable of disrupting entire ecosystems. Each piece alone was fascinating, but together they formed a picture too large for any one scientist to hold. The work required imagination as much as precision. A comet impact hypothesis emerged when tiny nanodiamonds and spherules were discovered in sediments dating to the Younger Dryas boundary. Some scientists argued these could only be formed under the intense heat of an extraterrestrial strike. Others countered with explanations tied to volcanism or lightning, urging caution before declaring a catastrophe from the skies. The debates themselves became part of the detective story, with teams across the globe testing, questioning, and challenging each other's evidence. What makes this pursuit so compelling is not only the mystery of the Younger Dryas, but also the excitement of linking disciplines that rarely overlap. Climatologists pore over microscopic isotopes. Archaeologists sift through fragments of bone and ash left by vanished cultures. Geologists map entire landscapes that hold memories older than language. Each speaks a different scientific language, yet all circle the same questions. What caused the sudden cold? How did it ripple across the globe? And what does it teach us about our own fragile climate balance? The thrill of discovery often comes in unexpected moments. A core drilled from the bottom of a lake in Scandinavia may suddenly align with pollen shifts seen in North America. A layer of charcoal in Syria may match a fire horizon found in South America. The realization that distant places bear the same signature is like uncovering fingerprints at a crime scene, confirming that the Younger Dryas was not a local accident, but a global upheaval. For those who study it, the Younger Dryas is more than an academic question. It is a reminder of Earth's volatility, of how climate can change in the span of a lifetime. Scientists describe the experience of standing before an ice core or an exposed cliff face and feeling the weight of that sudden transformation. The evidence speaks of a time when glaciers advanced, forests died, and cultures nearly disappeared, all in less than a century. To unravel that story is to touch the edges of human vulnerability and resilience alike. The detective work continues even now as new technologies reveal details once invisible. Radiocarbon dating refines the timeline of human collapse and migration. Geochemical analysis teases apart the origins of spherules and nanodiamonds. Computer models simulate the collapse of ocean circulation or the effects of comet impacts. Each tool sharpens the picture, yet each also deepens the questions. The story of the Younger Dryas has become a shared quest across disciplines, a puzzle passed from hand to hand, each adding new insight. What unites the effort is not only the search for truth, but the wonder of uncovering the past at a scale that binds together climate, landscapes, and the human journey. To watch these detectives at work is to see science not as dry data, but as a living narrative of curiosity, persistence, and the drive to understand the world that shaped us. The Younger Dryas has often been called one of the greatest mysteries in Earth's climate history. What force could plunge a warming world back into bitter cold for more than 1,000 years? Scientists have traced clues in ice, stone, and soil, yet the answers remain tangled in debate. Rival theories stand side by side, each offering pieces of the truth, but none fully capturing the whole. One of the most enduring explanations centers on the oceans. The idea is simple, yet powerful. The great conveyor belt of ocean circulation, which carries warm water northward and cold water southward, may have faltered. As the last ice age waned, glaciers melted at enormous speed, releasing floods of fresh water into the North Atlantic. This sudden dilution could have disrupted the sinking of dense, salty water that normally drives the conveyor. Without this circulation, heat from the tropics would have stayed trapped in southern latitudes, leaving the north to plunge into cold. Evidence from sediment cores supports this view. Layers show sudden shifts in the salinity of seawater, and modeling suggests that a shutdown of the conveyor could cool the northern hemisphere by several degrees within only a few decades. It is a compelling story, one that fits the timeline of the Younger Dryas with unsettling precision. Yet the oceans may not hold the whole answer. Another theory points not to water, but to fire from the sky. Scattered across the globe, at sites dating exactly to the start of the Younger Dryas, lie peculiar materials, nanodiamonds, tiny spherules, and bands of charcoal. These have been interpreted by some as the fingerprints of a cosmic impact. Perhaps a comet or fragments of a larger body struck the Earth, igniting wildfires and filling the atmosphere with dust. Such an event could have blocked sunlight, triggered firestorms, and set in motion the dramatic cooling seen in ice cores. The idea is bold, and it has drawn fascination both within science and far beyond. But it is also controversial. Some researchers argue that the particles can be explained by natural processes, such as volcanic eruptions or lightning strikes, rather than by an object from space. The evidence remains contested, and the debate continues. Volcanoes themselves form a third strand of explanation. Throughout history, eruptions have dimmed the skies and cooled the earth. When Mount Tambora erupted in the year 1815, it sent so much ash into the atmosphere that the following year became known as the year without a summer. The possibility that a large eruption, or perhaps a series of them, helped trigger the Younger Dryas cannot be dismissed. Sulfates in Greenland ice cores hint at volcanic activity around the time the cooling began, though the signatures are not as clear as those linked to more recent eruptions. Volcanic aerosols can cool the planet for a few years, but the Younger Dryas lasted for more than a millennium, which makes volcanoes a less satisfying answer on their own. Still, they may have amplified other forces, tipping the balance at a moment of fragility. The difficulty lies in the fact that none of these theories fits perfectly. The ocean circulation collapse explains much, yet it does not account for the strange particles in the boundary layer. The comet hypothesis explains the nanodiamonds and spherules, yet struggles to prove a crater or impact large enough to drive global cooling. Volcanic eruptions are known agents of change, but no known eruption of the time seems powerful enough to sustain such long-lasting effects. It is possible that the Younger Dryas was not the result of one single cause at all, but of several forces colliding in sequence, each amplifying the other. Science thrives in this uncertainty. Debate is not a weakness but a strength, forcing ideas to be tested, evidence to be scrutinized, and assumptions to be challenged. The Younger Dryas has become a kind of intellectual frontier where geologists, climatologists, and archaeologists gather to compare notes, each field holding pieces of the puzzle. Some argue passionately for their favored explanation, while others remind the community to remain cautious, to hold space for doubt until the evidence is overwhelming. For those outside the scientific world, the absence of a definitive answer may seem frustrating, yet within science, it is precisely this uncertainty that fuels discovery. Each core drilled, each sediment layer analyzed, and each fragment of microscopic dust studied brings the picture into sharper focus. Perhaps the truth lies in a combination of theories: a flood of fresh water slowing the ocean, a comet igniting fires that filled the skies, and volcanic aerosols adding their veil to the atmosphere. Or perhaps the real answer is one still undiscovered, waiting quietly in some unstudied deposit of ice or soil. What is certain is that the Younger Dryas stands as a reminder of how swiftly Earth can change and how even the most advanced models must contend with forces we do not yet fully understand. The debates about its cause continue, not because science has failed, but because the mystery is so vast and the evidence so intricate that solving it demands patience, imagination, and collaboration. The scars left on the land, the chemical signals frozen in ice, and the sudden disappearance of cultures remind us that the Younger Dryas was not just a scientific anomaly, but a lived reality for those who endured it. The search to understand its cause is also a search to honor their struggle, to read carefully the record they never intended to leave, but did, nonetheless, etched into the earth itself. The Younger Dryas is remembered not only for the cold it brought, but for the speed with which it arrived. In the sweep of Earth's long history, most changes take place slowly, unfolding over tens of thousands or even millions of years. Continents drift, mountain ranges rise, and ice sheets advance with a patience that no single lifetime can observe. Yet the Younger Dryas did not follow that rhythm. It was abrupt, and it showed that the planet is capable of transformations far swifter than the slow pulse we often imagine. Greenland's ice cores hold the clearest evidence of this pace. Within those frozen columns, each layer of snow preserved the air, dust, and temperature of a year long past. When scientists drilled deep and measured the isotopes locked inside, they saw a sharp step downward around 12,900 years ago. In fewer than 30 years, the northern hemisphere cooled by nearly 10 degrees Celsius. To those who lived then, it was not a distant geological shift. It was a change they could feel within their own lives, a winter that deepened year by year until the world seemed to forget its warming. This kind of speed is what makes the Younger Dryas so unsettling. It is not a story of patient glaciers edging across continents over millennia. It is the story of a climate tipping into a new state in the span of a few decades, as if a switch had been flipped. For people at the time, it meant watching forests wither back into tundra before their children were grown. Rivers froze sooner, growing seasons shortened, and animals that had once been reliable food sources dwindled in number. The lessons carried by that frozen horizon remind us that Earth's climate does not always change slowly. For scientists today, the Younger Dryas has become a prime example of abrupt climate change. It demonstrates that the planet's systems are not always gradual, but are sometimes fragile, sensitive to sudden jolts. A flood of fresh water into the ocean, a volcanic eruption, or perhaps a cosmic strike could be enough to push the balance past a tipping point. When that balance is lost, the results can be dramatic, swift, and difficult to reverse. What terrifies researchers is not only that such a thing happened once, but that it could happen again. Our modern world is already warming rapidly, driven by greenhouse gases rising in the atmosphere. The worry is that this warming could disturb the very systems that regulate climate. The Atlantic meridional overturning circulation, often described as the planet's heat engine, is one such system. It is the modern descendant of the ocean conveyor that may have faltered during the Younger Dryas. If it weakens or shuts down under the weight of melting ice and added fresh water, parts of the northern hemisphere could cool even as the rest of the globe grows hotter. The potential for sudden, uneven changes keeps scientists awake at night. The difference between decades and millennia matters deeply. When change takes thousands of years, ecosystems have time to adapt. Forests can shift their ranges, species can migrate, human cultures can develop new tools and strategies. But when change takes only 30 or 40 years, there is little time to adjust. Crops fail, animals vanish, and human societies struggle to reorganize fast enough. The Younger Dryas stands as a case study in how quickly a stable world can unravel when the climate shifts on a human timescale. For those who dig into its record, the Younger Dryas is less a distant curiosity than a mirror held up to our present. The abrupt onset of cold 12,000 years ago shows that Earth's systems are capable of lurching into new states suddenly. That knowledge forces modern climate science to consider not only slow trends, but also thresholds, points at which change accelerates beyond control. It is why models now try to account for tipping points in ice sheets, permafrost, and ocean currents, not just the steady rise of temperature. The unsettling part is that abruptness can be invisible until it is too late. People at the end of the Ice Age may have noticed shorter summers, longer frosts, and smaller herds, but few could have known they were witnessing the start of a millennium of cold. In the same way, scientists today caution that warning signs of tipping points may seem subtle until the shift is already underway. The Younger Dryas is the cautionary tale that proves the planet has leapt before and could leap again. Yet within its lessons lies more than fear. The study of abrupt change has sharpened our awareness of just how interconnected Earth's systems are. The air, oceans, ice, and living things form a delicate balance, and when one part is disturbed, the whole can sway. To understand the Younger Dryas is to glimpse not only the fragility of that balance, but also the resilience of life that endured it. Humanity survived, adapted, and emerged into the warmth of the Holocene, carrying forward the memory written in ice, soil, and stone. The mystery of the Younger Dryas remains, but its message is clear. Climate can shift suddenly within the span of a lifetime, altering the fate of species and shaping the course of human history. That lesson, carved into the boundary between Ice Age and Holocene, continues to echo in the work of scientists today, a reminder that abruptness is not only possible but woven into the story of our planet. The Younger Dryas is not only a story about the distant past, it casts a long shadow across the present, shaping the way scientists think about Earth's future. When researchers look back 12,000 years and see the planet tumble into a millennium of cold in less than a human lifetime, they are reminded that the climate system can shift abruptly in ways that defy our expectations of slow change. This event has become one of the key touchstones for modern climate science, not because it was the coldest time in history, but because of the speed and severity with which it unfolded. In the laboratories where ancient ice cores are measured, in the supercomputers that model ocean currents, and in the field studies of shifting rainfall and melting glaciers, the Younger Dryas stands as a constant point of comparison. It is treated as a test case for how Earth responds when something disrupts its balance. The event revealed that oceans, atmosphere, and ecosystems are linked in a delicate web, and if one strand is cut, the entire system may reconfigure itself. It showed that climate does not always behave like a slow-moving tide, but can sometimes turn like a storm, sudden and unstoppable. One of the most sobering lessons lies in the role of tipping points. During the Younger Dryas, a relatively small input of fresh water into the North Atlantic may have been enough to choke the circulation of the oceans. The collapse of that system redistributed heat across the globe and sent the northern hemisphere back into deep cold. What unsettles scientists today is how similar disruptions could happen again. The Greenland ice sheet is melting at an accelerating pace, pouring fresh water into the very same Atlantic waters. Each year adds more weight to the system, and while the modern climate is different from the Ice Age world, the parallels cannot be ignored. Modern climate models use the Younger Dryas as a benchmark for abrupt change. These models try to capture not only the gradual warming caused by greenhouse gases, but also the potential for sudden jumps. They ask questions like, what happens if Arctic sea ice vanishes faster than expected? What if thawing permafrost releases vast amounts of methane? What if warm water slips beneath the glaciers of Antarctica, accelerating their collapse? Each scenario echoes the warning written by the Younger Dryas, reminding us that the climate does not always shift politely, but sometimes lurches toward new states. The concern is not only about temperature, but also about the ripple effects on rainfall, food, and human survival. During the Younger Dryas, Africa saw lakes shrink to salt pans, Asia endured failed monsoons, and South America's rainforests weakened under drought. In a modern world of billions of people, dependent on stable harvests and predictable weather, similar disruptions could be catastrophic. The past shows us that when oceans falter and winds shift, whole regions can dry or flood in the span of a single generation. For many researchers, the Younger Dryas serves as both a warning and a teacher. It warns of how fragile the climate system can be, but it also teaches us how to recognize signs of instability. Ice cores and sediments provide not only a record of what happened, but also a blueprint of how the planet responds when pushed too far. Scientists study the isotopes, dust layers, and chemical fingerprints of that ancient freeze to better understand how Earth systems communicate with one another. They see the fingerprint of abruptness and know to watch for it today. The emotional weight of this lesson lies in its immediacy. People who lived through the Younger Dryas did not know they were caught in a planetary shift. To them, winters grew longer, herds thinned, and landscapes hardened. They felt only the strain of survival. We, however, can see the entire sweep of that history laid bare in the ground and the ice. And knowing what they could not, we carry a responsibility to learn from their experience. The shadow of the Younger Dryas hangs over modern discussions about climate thresholds. Policymakers, scientists, and ordinary people alike hear the term tipping point and often imagine something far away. Yet, the evidence of the past makes it clear that thresholds can be crossed in decades, well within a human lifetime. The abrupt nature of the Younger Dryas is what lingers most vividly in scientific memory, because it shows that climate change is not always slow and predictable, but sometimes fast, chaotic, and merciless. Still, there is another lesson hidden in that shadow. Humanity endured. Despite the cold, despite the hunger, people survived, adapted, and eventually flourished once the climate warmed again. That resilience offers hope, even as it underscores the importance of preparation. The Younger Dryas teaches us that survival requires flexibility, innovation, and awareness of the natural systems we depend upon. It is a reminder that although the planet can change swiftly, life can endure if it is ready to adapt. The ancient chill of the Younger Dryas is gone, but its message remains. It lingers in the way scientists model the climate, in the way they speak of abrupt shifts, and in the urgency they feel about today's warming world. It stands as proof that the Earth has turned sharply before and may do so again. The shadow it casts across our present is both a warning of fragility and a guide toward vigilance, telling us that the past is not silent but speaks to us still, if only we choose to listen. 12,000 years ago, the Earth paused on the edge of possibility. The great ice sheets had been retreating, rivers had been carving new paths across the land, and the first hints of villages and crops had begun to appear. It seemed as if the long winter of the Ice Age was fading into memory, and then, in a rush of decades, the warmth was stolen away. The Younger Dryas was not the deepest cold the planet had ever known, yet it was a cold that arrived at the very moment life seemed ready to step forward. The sudden chill pressed against forests and grasslands, turning them back into tundra. Animals that had once grazed in abundance were left with little to eat. Cultures that had been gathering in fertile valleys scattered once more, pulled back into the struggle for daily survival. Humanity itself seemed fragile, as though one more turn of harshness might have been enough to erase the chance of civilization before it had even begun. What lingers from that time is not only the ice and the hunger, but the way life managed to endure. In the bones left behind, in the pollen trapped in lake beds, in the faint traces of hearths and tools buried in soil, there is a record of persistence. Bands of people adjusted to the new cold, searching out food where it could be found, carving shelters against the wind, and holding on long enough for warmth to return. The fact that our species survived at all feels like a narrow thread stretched across a chasm. The Younger Dryas did not simply pass and leave the world unchanged. It reshaped the trajectory of everything that came after. The return of cold delayed the rise of agriculture, but when the warmth finally returned, it did so into a world that had been sharpened by struggle. The first farmers, the first villages, and eventually the first cities arose in the shadow of that long winter. Some historians and scientists wonder whether civilization would have unfolded differently, or at all, had the Younger Dryas not forced humanity to adapt with such intensity. There is a quiet poetry in how the name of that event was chosen. A small tundra flower, Dryas Octopetala, became its symbol. The petals of this delicate plant spread widely across the frozen landscapes, blooming in places where little else could. Its presence in the soil is how scientists first recognized the sudden return of Ice Age conditions. That fragile bloom, a sign of cold written into the earth itself, is a reminder of how the smallest witnesses can hold the memory of the greatest changes. The legacy of the Younger Dryas is felt not only in science, but in the stories humans have told ever since. Myths of great floods, of fire from the sky, of sudden darkness and long winters echo across many cultures. Whether these tales are direct memories or woven imaginings, they show how deeply climate shaped the human imagination. Even today, when people speak of worlds lost beneath water or skies darkened in anger, they are unknowingly echoing the kind of upheavals that once swept across real landscapes and real lives. To look back on this time is to see how close humanity came to faltering. Mammoths and saber-toothed cats, giant sloths and great birds, many of them vanished forever. The list of survivors is shorter than the list of what was lost, yet among the survivors was us. The resilience of small groups of people scattered across continents was enough to carry our lineage forward into the calmer climate that followed. Out of that endurance came agriculture, trade, written language, and eventually the complexity of the world we now know. The Younger Dryas is often called an anomaly, a sudden reversal in the pattern of warming, but perhaps it is more than that. Perhaps it is the reminder that Earth's story is never a straight line. It bends, it falters, it plunges into cold or heat without warning. The planet holds within it the power to shift its balance with startling speed, and in those shifts, the fate of every living thing can change. In the great sweep of history, the Younger Dryas stands as a hinge. On one side lay the Ice Age, with its glaciers and roaming herds. On the other side lay the Holocene, the warm and stable age in which all of recorded human history has unfolded. That hinge could easily have closed differently. Had the cold lasted longer or struck harder, the seeds of civilization might never have been planted. The winter that nearly erased us instead became the winter that set the stage for everything we would become. It is humbling to think that our entire story balances on that moment. Every word written, every city built, every dream imagined rests on the fact that 12,000 years ago, the cold finally lifted. The Younger Dryas reminds us that civilization was not inevitable, but precarious, born out of survival against odds. And so, when we look back at that time, it is not only with scientific curiosity, but with quiet gratitude. Gratitude for the unknown people who endured those frozen centuries. Gratitude for the fragile ecosystems that revived when warmth returned. Gratitude for the resilience written into the human story. The winter came suddenly, and it might have ended us, but instead it shaped us. Out of that unexpected cold, history itself was born.